So, good morning and good evening to everyone who joined from all parts of the world and registered for the great event. Hope you all your family are safe in COVID times. Our best wishes are with all of you. The half-day virtual event happening today will focus on how emerging technologies like AI, machine learning is transforming manufacturing sector. Along with the talks, we also have a 1 hour panel discussion with the theme, what will be the future of AI for manufacturing? Now to begin with, let me introduce myself and the company to you. So my name is Nitin Naveen and I am the Vice President Innovation and Strategy at AI CoreSpot. I'll be your host for the day. Further, I have been joined by my colleague Arvind and Naveen, who will also assist me lively and resolving technical glitches if it comes in between. So thanks a lot to them for putting in such a hard work and making this a huge success. We'll try to provide a seamless experience to all of you so that you can gain maximum output out of today's event. From AI Course Pod front to provide you an insight, we started this year, but gaining momentum as the time is tickling. Our aim is to be #1 AI-driven community all over the world so that like-minded people can be a part of the same in supporting, growing, and making it a success. Our mission is to serve as a hub for information regarding Industry 4.0 technologies, which encompass and not limited to AI, machine learning, deep learning, robotics, blockchain, IoT, edge computing, analytics, 5G, drone, edge AI, digital twin, AR, VR, cloud, and so on. We'll continue to do industry-backed webinars and hybrid events. The knowledge repository will be made from reliable data through industry leaders, subject matter experts, and thought leaders. We'll enrich the content through videos, blogs, podcasts, newsletters, digital content to shed light on the ever-evolving industry. Request all of you to go through our website, that is aicorespot.io, for further updates. Also, please like our social media handles, which will keep you all updated on everything what we propose to offer in the coming months to follow. Today's event is one series of events which we have planned for this month. It's power-packed with speakers' presentations and panel discussion themed around how AI is transforming manufacturing sector. On September 28, we also are coming up with a webinar with the theme Learn How AI is Transforming Manufacturing Sector. The timing is 8:45 a.m. CT to 10:15 a.m. CT. So it's around an hour time. So you all can register. We'll send details to all of you so that you do not miss out on the same. There are lots more in subsequent months as well, with focus on cybersecurity, telecom, IoT, and blockchain till December month. So request all of you to keep connected with us and enjoy the learning. Before starting with the day, I would like to highlight few things so that it can set up stone for such an amazing learning and networking day. A special mention to our technology partner Digit7, who has helped us in understanding our vision and supporting us to create a platform through which we can achieve our objectives. Their support is immense and we are here because of them. Some introduction about Digit7 to everyone so that you get to know. Innovation is the cornerstone of Digit7. Direction fills them with purpose. And purpose provides structure. So the visionaries at Digit7 realized this a quarter of a century ago, and they had ever since provided organizations with their strategic innovation roadmaps. They need to forge their futures. Innovation is their last name and disruption is their address. They create organizations with intuitive technology, equipping firms to endure accelerating change. The products which they offer are Smart Express Store, e-commerce, Grab and Go, Edge POS, Admin Store Management, Smart AR, Delivery Pickup App, Digital Wallet, Drone Scan, blockchain-based SCM, Label Monkey, Data Mink, and Digital Twin. The services they offer are product engineering, innovation as a service, which is called NAS, digital transformation, customer experiences, and innovation design. You can go through their website, which is digit7.io, and understand more in depth. We are joined by the CEO of Digit7, Chitrai Mani, who will also be the moderator in the panel discussion. Great thanks to him for bringing this all together. Also thanks to our community partners for today, which includes InfoVision, Siemens, Schneider Electric, Mars Digital Technologies, Pleura Technologies, Andres Automation, Slalom, Aware Group, Tech Resources Limited, Aware, Mata Inventive to make this event a huge success. Special mention to speakers and attendees of the event who registered and came today to achieve their objectives through this forum. At the end of the day, if you gain a few things out of this or get to know network with each other, our core objective as a platform will be achieved. Further, the last important point, which I want to bring to all of you guys notice, if anybody wants to ask questions, they can type in the Q&A section, which is there at the right corner of. You can type in as and when the speaker speaks, and we'll try to get it answered after each talk or as per the time permitted. There is also a hands button at the bottom of the screen through which you can even raise the hand and come to the stage to ask questions to speakers as well. Now I'll quickly go through the agenda and let you get introduced to the speakers and their topic for the day. Hope everybody can see the screen. So yeah, thank you. Thank you for the confirmation. So yeah, the time is 8:53 a.m. It is supposed to start at 9 a.m. We have Deepak Jose, who's Director Demand Analytics, Mars Digital Technologies. His topic is leveraging data and analytics to drive profitable growth. He will be the first speaker for the day. Then we have Jonathan, who is the President, Pleura Technologies, and his topic is reducing inspection errors, costs, and risk with hybrid AI. Then we have Arthur Gooch, Director of Innovation, Andres Automation. His topic is Artificial Intelligence Toolbox for Industrial Control. Then we have Harshad, who is Global Practice Head, Supply Chain, Slalom. His topic is Digital Innovation in Supply Chain. So yeah, we have 4 talks which will go at a stretch. We'll try to take a break of around 10 minutes. Then we have a panel discussion at 10:30 a.m. till 11:30 a.m. In the panel, we have Chitrey Mani, who's the Chief Technology and Innovation Officer, InfoVision, and he's also the CEO of Digit7. So he will be the moderator. We have Helenio Gilabert, who is Senior Director, Edge Solutions Industrial Automation Business, Schneider Electric, who will be also the moderator. We have Brandy Lefontaine, who's VP. She's VP and Chief Data Officer, Aware Group. Then we have Jamie Smith, VP of Products, Aware, and Jordan Lapp, Head of Product Tech Resources Limited. So we have great 5 speakers who will take the panel discussion, and the agenda is in front of you. What will be the future of AI for manufacturing? Then we have Jim Wilmot, who's Product Marketing Manager in Siemens. His topic is optimizing manufacturing with artificial intelligence. And then we have last talk for the day by Dr. Yan Shi Shang, founder and CEO of Mata Inventive. His topic is fusing artificial intelligence with equipment monitoring for manufacturing optimization. So yeah, this is great 11 speakers we have for half-day virtual event. So now I invite our first speaker for the day. So our first speaker is Deepak Jose. May we have Deepak? Yeah. So Deepak, you can share your presentation and I'll hand it over to you. Thank you.
Thank you very much. So good morning, good afternoon, and good evening, everyone. I am Deepak Jose. I am part of Mars Digital Transformation team. And before I get my presentation started, Nitin, can you confirm you can see the screen?
Yes, we can see the screen.
Okay, very good. Thanks everybody for joining. I am part of Mars Digital Technologies, and we drive digital transformation across globally for all the segment for us at Mars. At Mars, we believe the world we want tomorrow starts with how we do business today. I will start by sharing a quick video to tell you who we are as Mars. I hope all of you enjoyed the video. If I could, if I were in person, I would have started now by giving you some M&Ms and Snickers. Today, I'll be talking to all of you about leveraging data and analytics to drive profitable growth. In my agenda, there are some key themes that I'm going ahead with. I want to introduce Mars Digital and Mars Digital Engine. What is advanced analytics? It could mean different for different organizations. What does it mean for us? What is our data-driven innovation agenda, which is one of the use case within the entire manufacturing? I'll be sticking to one. What are some of the enablers of success? And depending on time, I'm happy to take any questions or later on connect with you as well. But let me start with digital transformation was a very complex concept. When the Mars Digital Technologies leadership team took charge, they wanted to explain digital transformation in a very simple terms to every Mars associate. We are more than 100 years old, more than 100,000 associate. We went ahead with a theme of speed, 100x speed. Growth, efficiency, and risk avoidance were the key things that we wanted to focus on. Now, as you know, Mars, in the video also, we operate in 80 plus different countries. This is one of the largest privately owned companies in the world with several billion-dollar brands. Mars Pet Care has brands like Pedigree, Royal Canin, which is on the pet nutrition side. But on the pet health side, we have pet hospitals like Banfield and VCA. A fun fact about Mars, Mars is one of the largest employers of veterinarians in the world. All of us are familiar with some of the Mars chocolates and gums like M&M, Snickers, Extra, and Mars food brands including Ben's Original Rice, Dolmio Pasta, etc. It's a very purpose-led organization. So when we started our journey it was very important for us to explain the digital transformation in a very simple way. And this is how we went ahead with it. We call it our Mars Digital Engine, which is always business-led and technology-enabled. What does it mean? Mars Digital Engine is a four-prong approach. First, you find the problem using user centricity and design thinking. It is more important to find the right problem than solving the problem right. That's our methodology. Putting consumers or the users in the heart of defining the problem. Once you find the problem, then you use AI, machine learning to solve for it. Once you find and solve, automation, this is where you free up the time and resources of the associates so that we can reinvest that time on something more valuable. And all of this is going to work if and only if we deliver in an agile manner. And what does agile mean? If you want to move from point A to point B, you don't need a Ferrari, you just need a skateboard. How can we build the progress over perfection mindset was very important. This is Mars Digital Engine, and this is being leveraged across all the digital technology associates in the organization. Now let me start telling you what does data and advanced analytics AI meant for the organization. Now, I'm sure that all of you are quite familiar with this framework. When we started in the organization with our digital transformation journey, we were seeing a lot of investment analytics and in technology were focused on descriptive and diagnostic, which is telling you what is happening in my business and why is it happening. But we took a position that, hey, we want to spend a lot of our time on predictive and prescriptive, which tells you what is likely to happen and what are the actions should I take. And prescriptive, which is the AI led approach, you will see more value even if the complexity is high. This was the foundation of our value led approach. Now, let me talk a little bit about the different approaches in analytics which existed in Mars in every organization and what is the position that we took. Now, I am not suggesting that one approach is better than the other, but this is what we have seen and we have taken this position. Now, I know several of you might have are part of IT organization, and I've been also in the past. So one generally an IT organization goes with a data-led approach, which focuses a lot on data automation to give the data to the business so that they can generate insights and subsequently take decisions. Now, there is an insights-led approach, which is traditionally in a manufacturing organization done by the CMI teams, the consumer marketing insights teams. Probably every 4 weeks or every month, you will get very good insights. They do some automation and they do some decision enablement, but it's more of fantastic insights. Now, when we started our journey at Mars, it was very important for us to be a decision enablement led approach or a value led approach. In simple words, that means if somebody asks me to do a pricing study or pricing analysis, the first question that we ask is, are you willing to have a tough negotiation with the retail partner of yours? Then we'll focus on it. For us, data and analytics does not only mean data to insights. The more important thing is insights to action so that your insights are implemented. And we did this by using a very simple framework. We call it the inverted pyramid approach. In any organization, we spend a lot of time in building a huge data asset, data lake, data mart. Decade back, it would take 1.5, 2 years to build a good data asset. Then we'll create knowledge and insights to generate some action to create some small value. And my encouragement to everybody is, how can you start with the value first approach so that you can think about what are the actions that you can take, and for that what are the insights that you need, and for that what is the data that you need to have. That is the change in approach that we implemented, and it is working really well for us. We are driving several hundreds of millions of dollars in profitability for the organization. Now, at this point, I want to showcase a little bit about how we are driving building the capability around innovation. Now, in any organization, innovation will be successful only if we do it with speed and if we have the right relevance. You can see any operating business moves at a logarithmic phase. But generally, the markets, technologies, and the consumers changes goes in an exponential phase. If the rate of change in the outside exceeds the rate of change in the inside, the end is near. I didn't tell that. That was told by Jack Welch, the CEO of GE. It is very important to drive things with speed, and that's where AI comes in. And for us, in this world, data sciences combined with behavioral sciences are the key enablers for creating innovation at speed. Data science, this is where the AI comes in, and the behavioral sciences, this is where you need to understand the user really, really well. And in the heart of it, the innovation happens. We think about innovation in 3 phases: the foresight to understand what is happening in the hidden pattern. You need to understand the deep consumer understanding. And finally, once you launch a new innovation, you need to deconstruct the product success and failure. And for us to build an ecosystem like this, it is very important to design the technology solution in the right way. And I'm going to tell you a small story before to explain how we should be designing the solution. Some of you might have heard this, so apologies. I'll be telling this story once again. Uh, there is in the Central American country Honduras. The country is quite known for its natural disasters, earthquake, hurricanes, etc. So in 1940s, the Honduran government collaborated with the US government to connect to vast majority of land. So this is, and they built a bridge which was built to last, to withstand the disasters. This is called the Choluteca Bridge. The construction was successful, but several years later, another hurricane hit the country called Hurricane Mitch. Because of the hurricane and the flooding, the river changed its course. Now you have a bridge with no water under the bridge. This bridge was built to last, but definitely not built to adapt. The reason why I tell this story, last year the pandemic hit us, and that was like a life changing event for a lot of us, for all of us. And that means that the technology, and for a manufacturer like us, the e-commerce business started accelerating, the consumer preferences started changing. So if we had built our capabilities in a build to last rather than in an agile adaptable way, we would have been in a situation like this. The reason why we tell this is to land this complex point. And if there is one slide which I want you to remember out of this conversation is this. I want to encourage all of you to build your AI solutions in an interconnected way. That means innovations lies in the heart of sales, strategic revenue management, marketing, supply chain forecasting. How can you build your solutions in an interconnected way? The second thing is, how can you build these capabilities in a reusable way? It is very easy to solve the problem once, but can you build it in a sustainable way is a bigger question. And the last thing is white box. This does not mean that you don't work with a SaaS provider, but make sure that when you build this, you understand the interconnectivity, what goes into the data foundation, what goes into the modeling layer, so that it can be connected to the ecosystem. How can your organization own the intellectual property, which is going to be very important. Now, we use this while building capabilities across all stages of innovation, which tells you what do our consumers need, what is the 4P strategies, which is going to support the concept, and what is the pricing promotion, and how can we define the goals and measure success throughout the launch. And these are the key capabilities. I talked to you about diagnostic, predictive, and prescriptive. Rather than only focusing on diagnostic, we focused a lot on predictive and prescriptive capabilities through all stages of innovation. And these are the capabilities that we are building, which we are sure that this is going to give a lot of strategic advantage to us, not only for now, but for a long time and specifically in the future. With this, I'll close my session by talking a little bit about the enablers of success. Now, how can you make an AI-driven initiative successful? It is very important to have the operating model right. We always told about the business-led and digital-enabled. This is what I start with, the Mars digital engine. The second biggest aspect is agile delivery. Now, how can you have a progress over perfection mindset? We did several minimum viable products, which are initiatives which can be as low as 2 weeks to a maximum of 12 weeks. We did a lot of experimentation, which helps, and the agile delivery mindset helped. And finally, the iterative mindset. Now, the iterative mindset, and this is one of the most important thing, as I would put it, it is we as data and analytics professionals, we don't have the silver bullet, but the mindset that we have should be iterative. You test, learn, take the learnings, put it back, And once you get into that loop of reinforced learning, we will be in a much better spot. So if there is one aspect about your initiative that I would like for you to consider, is building the right operating model. With this, I grew up in India, and Mother Teresa had a lot of influence in the way who I shaped up as a person. And she once quoted, "Not all of us can do great things, but we can do small things with great love." And the reason I want to, and this is something which resonates really well with me. What does it mean for me? We don't have to boil the ocean. We can focus on small things. We do it really, really well, and take that success to the next place. So my encouragement to all of you is, pick up those small things, do it really well, do a lot of small experiments, and you can be really successful in it. With this, I'm happy to take any questions. For us at Mars, uh, data and analytics, we call it our digital armor. We want, as we call ourselves, fellow Martians, to have the digital armor, which is going to help them move with a lot of speed. And I'm happy to take any questions at this moment. Thank you.
Thank you, Deepak. We'll just wait for some time, for a minute, if some questions are there from the audience. Guys, if any of you have a question, you can just type in the Q&A section, and Deepak will be happy to answer. It was such an opening, great, informative session from you, Deepak. Thanks a lot for bringing it all together and setting up the tone for the amazing day which we have for the manufacturing event.
Thank you. So I think, again, my offer to the audience here is, if you have any questions, it does not have to be now. Please feel free to reach out. You can connect with me on LinkedIn or Twitter, or these details are available with Nitin. And Nitin, please feel free to share it out to the larger audience. But I'm happy to take any questions if you have from this process. Okay.
So there is one question from Jamie Smith. What roles need to be educated regarding progress versus perfection?
That's a great question, Jamie. From a progress over perfection mindset, I think it should come from the organizational leadership as well. I think it is very important for our leaders to understand, in an agile delivery model, the first product is never going to be a Ferrari. It is always going to be a skateboard. So getting the leaders more comfortable with that approach is going to be very important. Now, I am talking about organization which is essentially not a digital native, which is more of a traditional organization. Now, in a new gen organization, the concept of agile is quite popular. Everybody knows about it. So the mindset is there, but I think I would start from the top. The second layer is, you need to have the right product owners. The product owners are going to make a significant role there as well. People with the right mindset. By a product owner, essentially, for me, they are the early adopters of something new that you are doing. So they are the ones who will be the biggest cheerleaders for your capability. You will these early adopters subsequently would influence the rest of the organization. So I think if there are the top two things, the leadership and the right product owners would be where we need to educate.
Thank you. Thank you, Deepak. Thank you for the explanation, and hope to see you in the near future as well. Stay connected with us. Thank you, Deepak.
Thanks, Nitin.
Thank you. So guys, we'll quickly move on to our next presenter. So we have Jonathan Howe, who is the President, Pleura Technologies, and his topic is reducing inspection errors, cost, and risk with hybrid AI. So may we have you, Jonathan, up on stage?
Yep. Can you guys hear me?
Yes.
Perfect.
Yeah, I can hear you. Yeah, we can hear you.
All right. Thanks. So I'll go ahead and share my screen and actually start with a kind of a demo just to illustrate the concept here. So clearly, like there's been a lot of technology in the world and how we do things. So what I'm going to do here is just kind of to illustrate the concept is digital transformation, right? You can do very neat things like what I'm doing here on screen today. And what I'm trying to illustrate here is, well, there's a lot of cool technology out there. We're living in this world of digital transformation for manufacturers, for AI. And clearly the technology exists. And what we're trying to do though is that gap, that hurdle that's still there is how do manufacturers get access to this technology? It's not whether the technology is there, it's how do you build these? And how do you do that in a non-technical way for guys like manufacturers, non-technical people in a no-code platform? So the basis of today's discussion and what we're going to be covering is around how to leverage AI in your factory and digital transformation. So I'll just pull up my slide deck here. And how do you combine technologies? How do you make it easy for users to reduce errors, improve quality through digital transformation with this hybrid AI approach? So some of the things that we're going to be talking about today, why manufacturers are evaluating AI, how to implement AI, how to make that easy to implement AI and computer vision for manufacturers. And then looking at different ways of how to build that in. So clearly there's interest to build AI into the manufacturing process, but we want to try to make it easy and kind of show how we can do this in a very streamlined way for improving your process. And then looking at kind of a future look at how cloud, how edge devices will all connect together. And really create this whole concept of the networked factory. So starting off with kind of the question of why are brands choosing AI? Why are we looking at AI for manufacturing processes? So you look at AI as a way to reduce errors that result in poor product quality, waste, or costly secondary screenings. You might have people doing some additional checks on the product. Looking at things like brand standards, safety, compliance, looking at challenging materials, metal, glass, fabric, wood, irregular shapes, things that are very difficult to inspect, where AI can help. And also kind of finally at the last point here, there's still a lot of manual process in the manufacturing industry where you have operators, you have human tasks, where we want to try to automate that so that you actually help the operators do things, just like the demo I showed at the beginning, where it could be things like instructions, augmented reality, and AI has the opportunity to help make that process simpler and more efficient for these manual processes. So when we look at kind of an end-to-end process from manufacturing standpoint, you can look at different areas where you're able to apply AI. So one of them being, let's say, your supply chain, checking your parts, what's coming in terms of incoming quality control. You want to make sure that you receive the right part, the specs are right, the right measurements, the right count, whether there's any defects in there. So that's one area where you can apply AI. Another area in terms of AI and more specifically vision AI is also in your setup process of your factory. How are we setting up the production lines? How are we setting up the test equipment and making sure that that's being done properly? So that you avoid things like ingredients mix-ups or producing the wrong product. Then you get into kind of the more traditional lines of where you think of vision and cameras and AI. This is inspection of the actual production of products. So you've got the use of AI here to reduce false positives. So clearly, some companies have vision systems. The benefit of using AI could be to complement existing systems to reduce false positives. Maybe use AI to inspect challenging materials that in the past it would be very difficult to inspect using traditional methods. To your regular quality checks in terms of checking the fill levels, the seal, to what I was just talking about in terms of automating manual inspection. So maybe you have an operator who's looking at a product and evaluating the quality in a subjective way, and you want to be able to automate that manual process, and you can do that with the AI technologies today. Then you think about, well, sorting and assembly. So sorting products, you can use AI for tasks like classification, to assembly instructions. How do I put things together? How do I follow the right instructions, and how do I make sure that the product is being built correctly? Take the example of building IKEA furniture. You've got instructions, and people interpret those in different ways, and then you kind of get upset at the end when kind of you forget a step, and then you have to go back, where you have some extra pieces lying around and you're not really sure why. So these are areas where kind of that interaction of AI with the workers can help prevent errors and improve quality. All the way to packaging and shipping, where you're talking about things like shipping labels, making sure that you've got the right label on there, it's not crooked, or you've not forgotten a label, and checking all of that in that final QA, QC process before the product is shipped out. So like I mentioned, the technology, right, it's really exciting. AI, you can do a lot. The question is, how do you do it, and how easy it is to do it? So when you're thinking from a manufacturer perspective, for someone who doesn't know how to code, who doesn't know any of the technical details, it could be a bit scary in terms of looking at how you deploy AI within the factory, especially when you're talking about from an infrastructure perspective. If you've already have investments in things like cameras, software, and controllers, you want to be thinking of, well, it doesn't really make sense to replace everything in the factory with a brand new system. You would want to leverage your existing cameras, if you have them, and make that work in conjunction with AI. The other part that I was trying to illustrate at the beginning was really how complicated is the development of AI. Do I need specialized skills? Do I need consultants to come in and build AI for everything? Well, that ends up really being very expensive, because every project, every automation that I want to run becomes a custom development project. And then I've got to start picking and choosing, well, where do I start first? And it actually becomes a longer time scale because of that complexity. And then the third aspect is, well, how do you maintain from a usability standpoint, from a user standpoint, people, operators in the factory who have been using tools and software that they're familiar with? Well, you don't want to suddenly change out all the tools that they've been using. You want to see how actually can I fit that in with existing tools and processes, and not really interrupt the workflow or the flow of what someone does in their day-to-day. So the next step here, kind of some background in terms of more technical, high-level overview of, well, what is AI versus what's our classical vision approaches. So I'm talking more about AI from the vision aspect. And when you talked about computer vision, machine vision, there's usually two approaches. You've got your traditional computer vision, traditional machine vision, where that works where features are being extracted, identified. So you might hear things like edge detection, corner detection, thresholding, and a developer goes in and handcrafts solutions. So they do trial and error, look at different values and see, well, how do I extract defects, or how do I extract an object from that image using that technique? So the disadvantage with this approach is that, well, every time you're trying to look for something new, it means I have to go back and find a new formula based on the new images or what I'm trying to find. With AI and deep learning, what's happened now is that process has been made simpler in terms of, well, I no longer need to be a developer to have to tweak thresholds and complex values. I can teach the system based on data that I capture and train models for the tasks that I want it to do. So how this works is you're working with images that you're passing, you're tagging the features that are part of that training process. And then it tries to mimic how we're thinking in terms of, well, if I'm trying to look for a red apple versus a green apple, you might think, well, let's first classify, is it a circle? Does it have a stem? What's the color? Is it red? Then you make that determination with a confidence value in terms of this is a red apple. So that's how it works. And there's pros and cons to both approaches, where traditional vision doesn't require lots of data. Deep learning AI does require data to be trained, but you don't need to do specific programming in the software tools that are available today. Where AI and deep learning excel, looking at object identification, segmenting a scene like you have here in the image, difficult texture, OCR, being able to read text on difficult distorted objects or dot matrix print, things like that. And the nice thing is really it can learn new tricks without having to rewrite code. So you can actually define based on what the user thinks and create a model based on that. And that can be extended to things like 3D hyperspectral imaging, so that you really enhance the quality by combining that together. So when you talk from a practical perspective, and how does someone deploy AI in a factory, you've got the concept of a hybrid AI. So when we're going back to that use case of product inspection, well, this is kind of a typical deployment where you can leverage AI. So typical challenges with some of these vision inspection systems, a high number of false positives. There's cost concerns related to AI expertise, to analytics. When you're building on data from AI, you also want to think about how do I capture data from a quality perspective so that we can improve on root causes or improve quality over time. And how we solve that is two approaches, right? Is the development approach and the deployment approach. So you start with kind of wanting to make it easy in terms of no code. Today in manufacturing and just in a lot of the enterprise applications, there's a lot of talk around no code, low code, and really making it easy for non-programmers to create the automations, because at the end of the day, the business person understands what they're looking for. So you want to equip them with tools that they can have to build their own apps for automation, for quality, and build that AI model, that app that will then run. And with edge devices now in IoT, well, you have a simple way now to deploy that throughout the factory at different spots. You don't need powerful servers to run these. You can run these at the edge. So how that would work would be, you can imagine the quality person or someone in charge of building these apps within the organization would build that through a no-code interface, transfer that to an edge device, connect their camera, and you can start inspecting your product and get the results that you're expecting, whether it's an accept or a reject of that product. So kind of really plug and play, right? Trying to make it simple so that it's no longer custom development. It's something that the brand, the manufacturer, has in their control to bring more of that AI expertise in-house for manufacturing. Another approach that kind of worth considering too is, well, maybe the full automation is not kind of the short-term goal. If you look throughout your factory, what are some of the challenges where you have manual tasks that are still in place that you can use a system to just help a worker perform their tasks better? So maybe not fully automated, but semi-automated, but augmented so that it helps improve the quality of a manual task. And an example here, right, is humans are well suited for inspection tasks, but if you get tired, if you get distracted, that can actually reduce the quality. You can let errors slip by. And in general, if you use your eyes to check something, if you use your eyes to do something, it's like me asking you to count how many black dots, black circles are in this slide. It's more subjective, and it could be it could change depending on the day, depending on the person. And what you see then, that translates into typical error rates of 20 to 30% when you're doing manual tasks like inspection. When you're talking about building products and following instructions, up to 62% error rate, depending on the complexity of what you're putting together. So some examples of tasks that are throughout the factory that could be automatable through AI, through vision, things like helping operators count, checking labeling, printing barcodes, again, checking whether things are crooked. It could be subjective. Is this crooked or not? Well, you use a camera, that's going to help you make that decision more objective. To checking product assembly, to digitizing work instructions and having kind of that augmented reality view where the operator actually can instruct or follow the instructions on screen and interact with these apps from the system. So you can imagine this process kind of where you install a system in the factory of the future where these operators, let's say this is an assembly station, you've got this set up there with a camera, with a monitor. They place the product in, they're shown step by step how to assemble the product. It includes a check to make sure that they've done it properly. So you're not necessarily interrupting that process of them assembling the product. It just kind of fits on top of their regular workflow. But the key thing to think about is, well, I've got a lot of products that I'm manufacturing. I've got a lot of things that I could automate. So how do I do that? And again, it's back to that no-code approach for AI and the importance of that for manufacturers so that it allows regular users to build their own quality apps, their own AI apps, bring that into the system so that I can easily automate and easily create things like instructions for the operators to do their jobs better. So what's next? So you've got very cool technologies around AI, you've got analytics, you've got edge devices. And what are we working towards from a factory perspective when we talk about putting all this together? Well, the evolution of how our factories can look like, how our manufacturing sites can look like, it's really a series of networked edge devices that are connected through networks like 5G that are running intelligent apps that are helping the workers do their jobs better. And all that is connected factory to factory in the cloud, where you can be using the cloud to manage your apps, to manage your training set, to share data, to create analytics, and really help connect all the devices between all your sites through the cloud. So I'd like to finish my presentation today around what we call our maturity model for Vision 4.0. And it really kind of helps you evaluate your journey as a manufacturer from how many manual processes do I have in my factory to the ultimate goal of that level 5 lights out automation. So if you start on the left, and you can really rate yourself in terms of where do you fit in this maturity model. Starting with human controlled level 0, where you're doing a lot of manual processes like manual inspection, you're relying on handwritten reports versus taking digital records of inspections. Early automation, when you start working with PC machine vision based products. Going to level 2, modern factory, where you start using network cameras, try to integrate with your factory systems like your MES and your ERP. IT/OT integrated, level 3, where you start leveraging some AI, you start using embedded devices in that connected network architecture. To level 4, digitally transformed, where you're really starting to deploy embedded IoT devices throughout the factory, leverage AI, leverage Wi-Fi 6 and 5G, different types of sensors, to the lights out, where you've been able to take the majority of all of the manual processes and deploy that in terms of edge devices that are talking to each other through Wi-Fi 6, 5G in the cloud, and using the cloud to manage these systems for the full automation. And with that, thank you for your time today, and I hopefully you enjoyed this presentation.
Yeah, Jonathan, thank you. It was a lovely presentation. I thoroughly enjoyed it, and I hope the audience also liked it. Thank you for giving a roadmap of what you need to do in all the stages and where your company is into. Thanks. It was a lovely presentation. Any questions, guys? Any one of you have? You can put up in the Q&A section, which is there on the right side. So you can put the questions in between also. It's not that you have to put at the end of the presentation. You can, if you have any questions, you can put it, and that saves some time. So yeah, how important is 5G?
Yeah, I mean 5G is definitely important in terms of one of the standards that are being used in the factories. There's basically competing standards, I think, between your traditional Wi-Fi approaches with 5G. 5G is being designed for a lot of these IoT vision applications. The wireless aspects enables kind of, I think, different ways to interact with technology. So that's where you're going to see kind of the rise of 5G, so that you're not limited to wired connections, but it has to kind of integrate with the rest of the devices in the factory.
Yeah, great. Hope Dr. Yen's question was answered. The second question by Jamie: what is the best way to integrate existing cameras?
Yeah, so existing cameras, when we were talking about industrial automation and manufacturing, when you're talking about network cameras, there are standards already in that. Gigi Vision is one of those standards. That's actually one standard that our company founded. And what that means is, because it's standards based, if you already have those cameras in industrial automation context, you can actually use those and plug into, for example, some of our edge devices, which we already support that technology. So that's that retrofit use case of using your existing cameras, plugging it into the new edge devices, but using new use cases around your existing infrastructure. So it's key to make sure that you are kind of following the standards, and most likely if you've got cameras in the manufacturing context, then it will be a standard like Gigi Vision.
So Charu has asked one question: in manufacturing domain, future of 3D printing can hamper your vision. Is it so?
The future of 3D printing?
Yeah.
Well, 3D printing, you still need to do quality checks, right? The print quality, just like 2D printing in the label and print industry, the quality is very important, because especially for brand companies like Mars, right? You don't want to have print defects. You don't want to have errors in that process. So you can see even 3D printing being a use case where cameras can inspect the quality of the 3D print to make sure the quality is good.
Yeah, thank you, Jonathan. Thank you for the lovely presentation and the lovely answers for the questions. Hope to
Thank
see
you.
you very soon. Hope to connect with you soon again. Thank you.
Thank you.
Thank you. So guys, we'll quickly move on to our next presentation by Arthur, who is Director of Innovation and Risk Automation. And his topic is Artificial Intelligence Toolbox for Industrial Control. So Arthur, over to you.
All right. Good morning, everyone. I hope you can all hear me just fine.
Yes.
Excellent. All right. So I'm going to give a slightly different perspective, looking at AI applications in industrial process control. So just a little bit about my background. I come from this as a mechatronics engineer, and I have a background in industrial process control, starting really at the basic things. So distributed control systems, largely in mineral processing applications and pulp mills. So lots of time in copper mining, and starting from the ground up of automation, making pumps and conveyors turn on and off. And from there, basically proceeded up the automatic control stack into AI. So I'm not really a data scientist or an AI practitioner primarily, but now I'm in a position as Director of Innovation of Andritz Automation, where I need to apply these sorts of concepts and manage these projects. And in this, I'm going to steer a little bit away from maintenance applications. These are certainly really important in industrial process control in the industries that I work in. I'm going to ignore them a little bit, but not to say that they're not important. It's just not so much been my professional focus or the focus of my particular division of the company. So any great undertaking requires a long-term objective, and we were fortunate enough to have this given to us by our CEO, who said outright that he wants us to be able to deliver a completely autonomous plant. Andritz is primarily an industrial equipment manufacturer, and Dr. Leitner's goal is that we can lay down equipment and have it be self-managing. And this comes with a number of advantages, largely in the consistency of decision making and better management of operator fatigue. Autonomous control brings with it the need for less human oversight. Humans, we find, are not well suited for monitoring large numbers of values for a long shift, which is generally the task given to industrial operators. Sitting in a chair for 12 hours, keeping track of a large quantity of data, and then consistently making good decisions, that's not really the best application of the human brain. So the more we can replace that with software and then allow the humans to focus more on higher level decision making and things that people are better at, we find that results in a lot of benefits for the plant, coming in terms of better throughput, efficiency, quality, and then equipment reliability, because the machinery is being operated more within its target parameters. And alongside with this, we also get some benefits to remote operation, where we have a number of facilities where consolidating the workforce into a single place is a benefit, or it allows us to move workers from a dangerous or inhospitable area or climate to a better place to work. So this is really the target that we're working towards. And this brings us to yet another 5-level view of autonomy, which I can go pretty quickly through because Jonathan was kind enough to do the heavy lifting of explaining how this works. But this is really analogous to how people are talking about self-driving cars. And this methodology has been applied industrially, where you have 5 levels of automation, in which level 5 would be the point where if it were a car, it doesn't need a steering wheel. And most industrial plants we find are somewhere in the level 1 or level 2. Level 2 is basically assistive functions where you have some degree of cruise control, but the operator by and large is still very much involved in the process. And this is sort of best practice for a lot of places at the moment. Level 3 is the point at which pretty much everything is self-managing to some degree, but the operator can briefly turn their back on the system but need to be able to intervene. At level 4, we have this mind-off automation where the operator can probably take a walk, have a response time of about 10 minutes. And for us, this is really the practical goal. Level 5 automation is quite some distance away, and we're not really focused on that in the moment. But what I do want to bring your attention to are some of the challenges around level 3, and this is really where you see self-driving cars get into the news, because you need a human who is monitoring the system and able to intervene, but not actively controlling. And this is just a really difficult thing to ask a person to do, to maintain situational awareness, focus on what's going on while not really doing anything actively, and stay in this state for a long period of time. So this is difficult for industrial operators as it is for drivers of self-driving cars who might perhaps want to take a little nap while their Tesla is on autopilot down the highway. So level 3 automation is a necessary technological jump, but this is something where for goal setting purposes, we try to focus our efforts on getting across this up to like a level 4, so that the system really is effectively self-managing and you don't need the operator to jump in quickly. But that gives us a framework, and now what I want to do is just talk to you about how we would approach the types of AI and how these would be delegated to different types of problems within the plant. So I would imagine that most of you, given that you're at an AI conference, have seen this Gartner chart, where you have this progression of analytics from descriptive to diagnostic to predictive to prescriptive, basically as an escalation of the complexity, where you start by describing the current state of things and gradually progressing up to making recommendations to then taking over the decision-making process. And this is a very logical flow. And yes, it does talk about increasing complexity, but when you're talking about industrial automation applications, we need to look at things a little bit differently, because in order to control a process, we need to handle a variety of different challenges. So I come at this as a controls engineer. I hope one or two of you have seen this kind of diagram before, but this is a really standard sort of starting point block diagram of industrial feedback control, where you have a reference, which is basically the target signal that you're trying to achieve. It gets compared to some value from a sensor. The difference between the two is the error. This gets passed to a controller that does some decision making, affects an actuator, which goes to the system, which is your process, and then that's the physical world, and then the physical world is measured again by the sensor. So this is all happening as a closed loop in real time, and this is feedback control. And most industrial automation problems fall into this general framework. A lot of them are handled pretty well already by existing technology, but equally a lot of them are not. And then this is where my role comes in, trying to figure out how to apply AI to help this particular chain out and solve problems relating to it. So we can split this up into sort of 3 areas, which are two of them are AI. These are or potentially AI. These are the 2 on the left that are relevant to our work, which is the decision making, which is the controller, and measurement, which is the sensor. On the right, we have the hardware and robotics, which is basically the physical actuator in the field. Definitely a very necessary part of the system, but not so much my focus. And for us, this doesn't wind up being as wrapped up in AI. So this sort of breaks up the Gartner descriptive to predictive hierarchy a little bit, because we have understanding the system state is the measurement, and we have decision making, which is the control. So for us, one is not necessarily better than the other, and we may have problems where a measurement AI solution is all you need, and we may have problems where a decision making AI is all you need, and you can really just go into one or the other to solve the problem. Now, taking a look at how these AI solutions are proposed, there's a real danger, and hopefully I think the industry is moving a little bit past this, where we start with a bunch of data, it goes into some sort of black box of machine learning, and at some point reaches critical mass and dollars fly out. Trying to stick with the theme of being a very boring, pragmatic controls engineer, this is not really how AI automation works in the real world. What we wind up is small cores of machine learning that are being wrapped in classical AI and good software engineering. And the idea is you can start with a small kernel of machine learning to benefit some aspect of the process. And then over time, we wind up with more little AI functions that gradually subsume the original symbolic logic. This can also be described as code 1.0 or code 2.0. This terminology is popular in some circles, but this is just sort of for introduction of it. But the code 1.0 is basically the existing code base, which is written in the conventional way by people. There's a lot of very good algorithms that we're still doing in this space. And then code 2.0 is what's learned by machines. So you have this machine learning model, which is gradually expanding within the application. So thinking about this and how this proceeds in terms of the different types of technology that we need to enable each one of these automation levels, we can sort of start at level 2 with a number of proven existing technologies, and a lot of the level 2 enabling functions are not really AI at all. Model predictive control and expert systems have been around easily for 20 years, and then we can wind up with some very narrow, precise machine control. Recently did a prototype in reinforcement learning to do equipment control, which manages a particular aspect of a particular machine, and that was quite successful. But really at level 2, we're talking about like a supervised cruise control. Level 3 automation is really characterized by the system having a good understanding of the plant state and is able to then alert a person to any problems. So you don't necessarily need the person watching all of the details at the same time. And level 3 is effectively about alarming for us. So that the technologies that fit into this are digital twins, which can either be machine learning based on history, or you can involve physically based modeling, which isn't really an AI technology at all. For us, enhanced sensors would be application of new types of sensors to the process. So a lot of the development here is in computer vision and audio sensors and things that are designed to replace what humans might take for granted when operating a process, and then supporting these with AI-based fault detection routines. And this is also where the predictive maintenance gets in. Level 4 automation, which is the automatic fault reaction, is sort of the defining characteristic here. Level 4 is primarily a decision-making leap for technology, and this happens on two fronts. One of them's the supervisory sort of optimization layer, and then the other is the emergency fault response. And then at level 5, we wind up with the fully autonomous control, where you have, again, more decision-making in production planning and emergency management. So just so it's not all me talking, what I want to do is give you a little demo. And I'll give a quick intro and then start the demo running. So what we have here on the left is a flow sheet of a piece of an industrial process from a simulation package. This is part of a copper grinding process. And what we have in this process is a measurement of particle size being discharged from a mill. And like many measurements in many plants, this is a lab sample point, which comes to us every half hour or so. So I will just get the video running. So what we have here is something that I recorded yesterday. And we have a piece of software that my company makes, and it's an automatic machine learning designed to create a digital twin for this particular data. So what we want to do is we have this lab measurement. It's measured every 30 minutes. And this is very informative to a person. But if you're talking about closed loop industrial control, it's not really that useful. What we'd really like is a continuous measurement. So what we're going to do is use machine learning to upgrade a 30-minute measurement into something that gives us effectively a continuous signal. So I'll expand this just a little bit so you can see what's going on. So we start with reading in the historical data, and we're going to do some quick automatic data cleansing, and then this will get built into a model which gives us what we're after. So starting off, we need to add some of the tags from the process that we think will be relevant. Very similar to what Jonathan said, the objective here is really to enable a process engineer, or effectively a person with domain knowledge, to deploy an AI solution without needing a bunch of coding or data science expertise themselves. So in this case, adding the tags relevant to the problem is really the person who knows the process having an understanding of what parameters around we think are going to be relevant. And we could add a tremendous number of parameters if we don't really know, but that's going to be basically just going to add computational load. So we try to optimize our modeling a little bit by adding values that are particularly relevant. So we just add a couple of these, and I can just skip this ahead a little bit. So now we have a bunch of tags added. We select the parameters for the model we want, and we can start the training process. So this is a tool that we deploy to our engineers who work with both our own equipment and then also as a consulting practice for helping clients' facilities. So one of our staff would basically deploy this at a client site and then use the system to set up and deploy machine learning models inside their primary control network. So time was accelerated a little bit on that model training. Realistically, that would have taken about 10 minutes. What we have is a model score of 94%, which is a very abstract number, but basically that's just telling us that we think we got a reasonable correlation between our inputs and some sort of continuous measurement. There's some statistics about how many different machine learning models were tested, and now we can take a look at the model output. And this is the zooming in, but it's probably easier to see in the PowerPoint version. So what you see here is the black, where the sampled measurements, and the blue line is the continuous value. And then this is something which we can feed back directly into an online control scheme. So this would be an example of AI being deployed on the measurement side. And then you could probably, in this case, use a very simple classical algorithm on the decision side to benefit you. So I hope this was one example of something you think you might be able to deploy in your process. And with that, I thank you for your time. And if there's a moment for any questions, I'm happy to answer them.
Thank you, Arthur. Yeah, thank you for the lovely demo on the digital twins. So there's a question for you. Is semiconductor fabrication mostly at level 4?
I'm not terribly familiar with semiconductor fabrication, so I'm probably not the best person to answer that. I think from what I've seen, line manufacturing is probably more automated than a lot of primary industrial process control. So different industries are probably going to slot in at different levels by default.
Thank you. Thank you, Arthur. Any other question, guys? Let me see. Okay. No. Thank you, Arthur. Thank you for the lovely presentation, and hope to connect with you sooner or later.
Thank you.
Thank you. Have a lovely day ahead and a lovely weekend to you too. Thank you. Bye. So as we'll quickly move on to our next presenter, which is Harshad Kanvinde, Global Practice Head Supply Chain Slalom. And his topic is digital innovation and supply chain. So may we have Harshad taking the stage?
Thank you, Naveen, and hello, everyone. Thanks for having me here. let's spend next 20 minutes, I think, discussing digital innovation in supply chain. So before that, Naveen, let me start presenting, and if you could please check if
Absolutely.
you can see the screen, that would be great.
Yeah.
Give me 1 second, okay?
Yeah, no issues. In the meanwhile, I'll just repeat, guys, if you have any question, just type in the Q&A section, which is at the right side, so that we are on time. And if any time is left, we can ask the respected speakers. Yeah, Harshal, over to you. We can see this presentation now, crisp and clear.
And can you hear me as well?
Yes, absolutely.
Okay, because I see the mute button on.
I know.
But anyway, so I think thanks for the opportunity, Nitin. As I said earlier, so I'll be talking about digital innovation in supply chain. So before that, a little bit of introduction of who Slalom is and who I am. So Slalom is a modern consulting firm. We do business as well as technology consulting, and specifically across strategy, business transformations, as well as software development, analytics, and business application integration. We are a digital native company, so it's founded in 2001, and have done a bunch of things, matter of relevance here, AI, machine learning, and other technological advances as we see in IoT and big data, cloud, as well as a lot of new ways of thinking about strategy and business transformation. My personal background, so I lead, as Nitin mentioned, I started and run now the supply chain practice for Slalom globally across our 40 offices in the United States, as well as our markets that we serve in Canada, UK, Japan, and Australia, and some markets in Europe. The theme for our work has always been agility in supply chain. So how do you build flexibility, responsiveness, and speed in supply chain using digital innovation? So we'll touch upon that a little bit. Before Slalom, I was with Amazon in Seattle, and I was leading the transportation and inventory allocation initiative. So both the product side as well as day-to-day operation for fulfillment by Amazon. And prior to that, I was with another consulting firm, EY, where I was fortunate enough to have an opportunity to start a new business, which was a joint venture with Procter & Gamble. And the idea was, Procter & Gamble has really great know-how in new product development, manufacturing, and product innovation, as well as supply network design. Can we commercialize that know-how and take that know-how to serve our other clients in the non-competing to P&G, but other clients in CPG, process manufacturing kind of sector. So overall, 15 odd years of experience in this space across manufacturing, planning, logistics, and as well as business innovation and business model innovation. And you'll see all that kind of that perspective I want to share with you, gained over the last 15 years. And hopefully you enjoy. And please, as Nitin mentioned, keep the questions coming. We'll make sure that we'll answer most of those. Nitin, I'm having trouble moving the slides forward.
Okay.
Yeah. Got it. So as I think the nature of this presentation will be slightly different than the previous speakers. We'll be talking more on the business side than the technology. But I think before I do that, so AI, I mean, it's no doubt you are here at the conference because you know the potential of AI for positively impacting end-to-end supply chain performance. We practice that, we see that day in, day out. As a company and as a supply chain practice within the company, we have done many of these use cases, helped clients in multiple different sectors with many of these use cases. Some of the more profound ones are computer vision, using computer vision for improving quality on the lines, as well as using AI for improving supply and demand forecasting, predictive maintenance, optimizing inventory performance. So where should be my inventory, having it in the right place at the right time in the right quantity, so that you impact the transportation cost, you impact warehousing cost, and so on. Also, we are seeing a lot of impact. So when supply chain drops the ball, it's not just the supply chain that gets hurt, but customer service and your commercial side of the business gets hurt as well. So using NLP and other AI techniques to improve the customer service performance improvement. So all those different use cases, I'm sure that you're reading a lot about it, you're practicing that, and it's nothing new to you. The challenge is that we do all these different things, and we have seen many examples. But then the key question I keep personally asking myself, and really curious about it, that why do we rarely see that potential realized at scale? I mean, if you think about even the modern form of AI, I'm not talking about the mathematics behind it being around for a long time, but even the cloud-enabled, big data-enabled AI that we see today, it's been around for a while now. And there have been lots of pilots and lots of POCs and lots of initiatives where people are putting money and everyone is talking about digital transformation. But why do we rarely see that at scale at many companies? There are some shining examples, of course, but I would say bunch of it remains at curiosity and a lot of lip service than getting realized and having a real impact on the bottom line or customer performance, customer service. One of the key root causes, as we see, and based on past several years of experience, is essentially this I'm a hammer looking for the nail kind of syndrome. There are a bunch of other root causes as well, but essentially it comes down to that many times the narrative starts with, hey, let's do something with AI. And then figure out the use cases. It has to be the opposite way, right? But hammer looking for nail, what we have experienced that often one of the key root causes why we see the potential not realized the way it should be. This is one of my favorite quotes. Amazon has influenced me in more than one ways, my thinking and how I think about these things. But one of the things that we really embody as we think about supply chain and as we think about digital innovation in supply chain is true disruption happens in customer adoption. True disruption doesn't happen in technology innovation necessarily. So technology innovation in vacuum without having that linkage and that logical link to what happens at the customer moment of truth, it doesn't go anywhere. So true disruption happens in customer adoption. Most of these examples that you see on the right hand side, Uber disrupting taxi industry, or Airbnb disrupting the hotel industry, or Netflix, there is that innate customer need. There is always a story that an inventor inventing on behalf of the customers. Customers might not be asking it at the time, but somehow that internalizing what real customer needs are, what jobs the customers are trying to accomplish, and reading between the lines and then working backward from that customer view, and then creating solutions to solve those problems. That almost always the key. When you do that right, innovation at scale happens. When you don't do that right, then you have this pilot purgatory. That there are a bunch of pilots and POCs, but nothing happens because you're not trying to solve the real problem that will actually impact someone's life in a meaningful way. So we take this very seriously as we think about supply chain innovation or digital innovation in supply chain to get toward that agility in supply chain vision. So as I said, focusing on the real problems that your customers, and customers don't necessarily need to be external customers all the time. It could be your internal stakeholders you're trying to solve. I think that the thing that I said about meaningfully impacting someone's life, I think that's super important. Focusing on the real problems, it's super important. But then again, the question is, how do you find those real problems, right? So focus on real problems, solve those problems really fast, pretty straightforward, pretty logical. Some of the observations from the past several years of working in this sector and working with chief supply chain officers, chief manufacturing officers, and helping them on this journey. As you see on the screen, try to invent painkillers and not vitamins. Super important. When you internalize what problems your internal or external stakeholders are facing, and you go after those specific problems and solve those. So in other words, invent those painkillers. Adoption becomes that much easier. Then you'll seldom then find yourself, if you do that well, in a situation where, hey, I have invented this, Now, you know what, my users don't understand it, they just don't get it, I need 6 months of change management effort. If you're in that situation, probably you didn't find the right problem, or you didn't internalize the problem the right way. But if you internalize that the right way, then and identify how to invent the painkillers, then adoption becomes that much easier. Again, the second key core tenet that we follow is that things that are easy to maintain and easy to use at enterprise level scale, but don't really solve the specific problems that people are facing, are not going to go anywhere. And many times this happens. So many times we are in this situation where even before you really understand what the problem you are trying to solve, and what's the shape and a shape of that problem, and really trying to kind of deconstruct that problem, many times people get hung up on, hey, can I maintain that at scale? Do I have capabilities to maintain that solution? Can I scale it at all my locations? So people think about scale prematurely. People think about maintainability prematurely, even before they understand the problem really well. And again, often, if you get on that path, it's hard to kind of get back. And after 6 months and 1 year's worth of effort, and typically those solutions are not going to solve the problem, are not going to be adopted, not going to be scaled effectively. The third thing, most important thing, is you have to be practical. You have to move fast. Perfection is the enemy of good, right? So a good solution that works is better than a perfect solution that just stays on the paper and stays on the presentation decks. So identifying that problem, internalizing that problem, and then having this cadence of every few weeks or every quarter at least, you are delivering tangible value. You are inching your way forward to solve that problem. You're not going to solve anything perfectly in the first go. You have to have that iterative mindset, but at the same time moving fast and being practical, working with your constraints and understanding your constraints, what you're dealing with in your situation, and then still making progress day by day. I think that's super important. So many times we find leaders and doers in many companies get hung up on the fact that it might not be perfect. We might have to do a do-over. We might be creating throwaway work, and just that creates this analysis paralysis that people don't move, and years go by and nothing had changed. So a couple of things. Then, how do you find what problems to solve? Where do you find those, and how do you know which problems to solve first? Those are non-trivial questions. It may seems logical that go after real problem, internalize real problems, and just do all these things to move fast, but that's not easy. I mean, there are always so many different ideas. When you're looking at Fortune 500 companies, or even companies with $1 billion revenue, or even a couple of $100 million, so many people and so many complex things happening at the time. How do you identify which problems to solve? And that's not a trivial thing. So a simple framework that we use, the ship and the speedboat, there signifies the agility that I was talking to. So having that uber goal of how can I make my supply chain, and by supply chain I mean procure, plan, make, and deliver all aspects of supply chain. By making agility as a goal, that you want to build this flexible, responsive, fast supply chain without breaking the bank. Then the things that we have identified are super important and helps us identify those problems to solve. Is to get agility, you need to have three things. You need to know what's going on in your supply chain. It could mean visibility into your inventory, visibility into your assets, and productivity of your labor force. But also equally important is visibility into your decisions that different operators are making at different nodes in your supply chain. Then the predictability, that having an ability to predict the scenarios, and then focusing on those what if scenarios so that you can make better decisions day in and day out, the operational decisions, not just the strategic decisions. And finally, the most important thing is act. So no matter of visibility and predictability and the insights that you generate from those are going to help you, unless you build mechanisms so that your shop floor operators and your warehouse managers and your other frontline workers can act on those insights. So building mechanisms so that your operators can act on these beautiful insights, that becomes super important. And then going back to identifying the problems and prioritizing the problems, you got to ask yourself questions that where do I stand in terms of no? If I have this goal of reducing my transportation cost in Latin America by these many percentage, what's really the root cause? Do I really know where my inventory is? Do I know whether the inventory is in the right place in the right quantities and how that impacts your transportation cost? So know, predict, and act, that framework gives you that mental model to think about these problems and then identify which problems are going to impact most compared to the others. You all know this. So again, going back to why digital innovation, right? So in our experience, agility in supply chain or having meaningful impact in terms of visibility or know, predict, and act, you'll reach the limit really fast unless you are smart about how to use digital innovations that are available at your disposal. So those could be Internet of Things, it could be big data, cloud computing, machine learning, and so on. But being smart about orchestrating among all those different levers that you have available so that you can impact the visibility, predictability, and action, that becomes of paramount importance. Again, coming back to the earlier quote, true disruption happens in customer adoption. So always having that mindset, and bunch of that mindset has to be set, and the tone needs to be set by the leadership in the companies, and then that percolates down to the operator on the line. But you have to keep asking questions. The stuff that I'm doing, the things that I'm investing in, how does it impact my customer? Am I doing just the busy work? Am I doing some high school science project that might not see the light of the day? Or is it really there is a logical story that if I do this, this is how it impacts my external or internal customer? There are always going to be uncertainties, and you're not going to have all the answers. Bunch of things in that narrative will be blanks that you need to fill with additional research, additional experimentation. But unless, if you don't even have that logical narrative in place right now, that I do XYZ, I use AI to improve my, for example, I use AI to improve my sales order forecasting so that I can have a really good distribution plan in place, and I can impact then right inventory in the right place in right quantity so that I can improve my on-time delivery. Unless you have that logical story right at the beginning, you're going on the wrong path. And to get that, the funny thing is, to get that logical story in place, you don't need 6 months of strategy engagement. Most of your people already know those answers. Just getting those answers in one place and coherently telling that story so that everyone is talking the same language, that's where most of the things start failing. And taking those few weeks upfront investment from the right people, having the right people in the room at the table, that makes the difference. That makes a big difference in identifying the right things to solve for. And the technology, I'm not, by no means I'm saying that the technology element is easy, but it becomes straightforward. You can identify the right experts, and externally, internally, you can form those right partnerships. We have seen great presentations from so many experts today itself. But that becomes straightforward. As I like to say, that you as the company leader, you own the problems. You can't delegate that to someone else. You own the problems. You need to have a really good narrative how your problems impacting your customers, and there is no just negative connotation. So problems is one broader generic way to say it, but it's not that you are doing this just to fix something that's broken, but you're also, when you internalize with what customers are trying to do, that opens up new opportunities for your business growth that you can go after using technology. So that narrative goes both ways, the problems, the disruption, as well as new opportunities for business growth. But you need to have that narrative. You own that. Once you have that, I think engaging with the external partners becomes that much easier, and then technology becomes that much straightforward. So with that, I want to thank you all for this opportunity, and happy to answer any questions.
Thank you, Harshad. Yeah, it was a lovely presentation, absorbing one. Thanks for giving practical insights to everyone. And that too said by Charu also. Yeah, great session. Congratulations. There's one question from Charu, Harshad, to you. Can AI model implemented in big corporation will adopt by small companies as well?
If you mean by, I mean, there are a couple of ways to answer that. So one is just the simple inspiration, right? So Amazon is doing all these different things. Can I do the exact same thing? Yes. The stuff that you build for your company, can you just take it and use it as a plug and play for other companies? Rarely, in my experience, because the nuances of every company are going to be so different. And even within a company, if I look at a Fortune 500 company, let's say $20 billion company, operations in every country in around the world, the solution that's going to be useful in Brazil might not work in the same fashion in Germany. You are going to have those nuances that you need to tweak. But as a inspiration or as a starting point, absolutely yes.
Yeah. Thank you, Arshad. Thank you. Yeah, it's a correct way to, I think, interpret. Every region is different. Every company is different. But the base remains same.
Yes.
Thank you. Thank you. Any other question, guys? If you have, you can just type in the Q&A section. Okay, speaker PPT available. Yeah, we'll get all the speaker PPTs and we'll pass it on to all the participants who have attended the event. Thank you, Arshad. Thank you for the lovely presentation, and it was nice hearing practical aspects from you.
Thanks, Nitin. Thanks for the opportunity, and talk to you soon. Bye.
Yeah, talk to you soon, and hope the audience and the other speakers also learned a lot of things from you. I think it was a lovely one. Thanks, Harshad. So, guys, now time is 10:22 a.m. So the next panel discussion is in the next 8 minutes. So we'll connect at 10:28. That is in the next 6 minutes. We'll take a break now. And in the next 6 minutes, we'll connect with all the panel members for a lovely panel discussion of around 1 hour. Thank you. Hi.
Hello.
So everyone is present now? Yeah, okay. We have all the panel members. So let's start the day for the panel discussion. I'll let all the panel members do the talking, but I'll just introduce the panel discussion theme. So theme is what will be the future of AI for manufacturing. And we have all the panel members here. So I'll want Helenio to take the stage and Chitrai to follow up and then carry on with the conversation. It's around an hour's time. Yeah. Helenio, over to you now.
Thanks, Nitin, and thank you, everybody, for joining us today. My name is Helenio Gilabert, and I'm the Senior Director for Edge Solutions at Schneider Electric. And today, we're here to talk about a very, very good topic, a very amazing topic, which is the future of artificial intelligence in manufacturing. And we'll be talking about the big trends that you should be keeping an eye on that could directly impact your business. Our goal today is that whatever your role in the industry, that you will come out with some ideas, some new thoughts on some new things that you can try or explore that will bring value to your business. For today's format, we're going to try to follow the following. We'll take a few moments for each of the panelists to introduce themselves. Then I will kick off the session asking a question, and we'll engage in conversation. And as we go, please feel free to submit questions, because we much rather discuss the topics that you want to hear about. And to make sure we do that, let us know what those questions are, and we'll introduce them to the panelists. Sounds good? So with that, let's start with introductions. And Brandy, if you would like to go first.
Sure. My name is Brandy LaFontaine, and I'm currently the Vice President and Chief Data Officer of the Obari Group. We're a holding company that has a series of different organizations within our portfolio that spans everything from marketing agencies, so supporting large-scale enterprises, predominantly in the multi-franchise units, with helping them to maximize their media spend and really engaging with them as a creative partner so that they can drive additional value for their clients, both franchise level as well as direct B2C clients. On top of that, we also have a series of organizations that manufacture, develop products, predominantly in the outdoor space, which we then go right from manufacturing development all the way through to the brick and mortar and e-commerce sales platforms. So we're out there in the market selling those products and driving engagement. And as the Chief Data Officer, my responsibility spans everything from data governance, data engineering, right through to maximizing the value from our data assets at each one of the organizations that we have an opportunity and really an honor to support in their journey of development. Some of the things that we're the most excited about at the organization right now is developing attribution models, optimization of media, and really maximizing the value of the spend from our clients. Prior to working with the Obari Group, I've had the opportunity to work across a myriad of industries. And I think that that's one of the things that's the most interesting is that AI is this common language. Data is a common concept across all of the industries that I've had the opportunity to work with. We all face the same problems, but the opportunities to maximize the value from your data are consistent. WestJet, we did revenue management, really learning how to build those algorithms to maximize the value of every single seat. So selling the right seat, the right price to the right customer. And it's about finding those opportunities to generate incremental value. After that, I had an opportunity to work with NMAX and an absolutely amazing group of citizen data scientists, actual data scientists, and helping them to maximize their customer value. How do you understand churn? How do you understand when somebody's going to leave your organization before they even think to do so? So you can intervene and keep them with you. Finning International, absolutely amazing experience. Had the opportunity to be their global pricing director, as well as working across developing their domain analytics foundation and working with their data science team to really work within the Caterpillar's automation and IoT to drive value for our clients. As a service provider for Caterpillar, it's important for us to really understand the best way to keep those machines up and running all of the time so that our clients are always in the market and always moving. And then after that, working with Benevity, a software as a service company, and they're transforming the world through purpose. And really, again, at the end of the day, it's about understanding the customer first and how do you drive those solutions that provide value for the organization so that they can make the best use of their data assets.
Thank you, Brandy. That's very impressive. Jordan, would you like to go next?
Great, thank you. Thanks for having me. I am Jordan Lapp. I'm the head of product at Tech Resources, which is Canada's largest diversified resource company, mainly mining. To give you an idea of our size, 4 of our mines in the Elk Valley in British Columbia are about 1% of Canada's GDP. So we are by far Western Canada's largest shipper. We send about 4 to 5 fully loaded trains to our ports in Vancouver every day. We deal mainly in copper, zinc, and clean coal, metallurgical coal. So the project that we're involved in right now is a digital transformation. Mining right now is undergoing the same kind of transformation that forestry went through in the 90s. It used to be in the 90s, you'd have a bunch of lumberjacks that would go out and harvest trees. float them down rivers, etc. Nowadays, there are no forestry companies. There are robotics companies that sell wood. In 10 to 15 years, there won't be any mining companies. There'll be software companies that sell minerals, right, in the same way. Some of the work that we're doing, we've generated about $840 million over the past 18 months in margin uplift. So most of you might know that the difference between margin uplift and cost cutting is that margin uplift, we're reducing waste, not cutting costs, right? So there's a crucial difference. And in mining, waste usually goes into the environment, right? Like, unfortunately, it's a dirty industry. To give you an example, we have those 9-foot tall haul truck tires, right? The haul trucks are 420 tons. They're quite large. So those tires, they're not recyclable. We have permission from the government to bury them in certain locations. So one of the projects that we're undertaking is to increase the lifespan of those tires, which means fewer tires that are buried, and you save in the greenhouse gases in producing those tires as well. And the savings is not insubstantial. Like, we can increase the lifespan of those tires by 300 to 400%, and we might be able to achieve 2,000 to 3,000% using data analytics. And one of the ways that we do that is those tires, as you can imagine, 420 tons on them, they're under a huge load, right? They're very high pressure. Often they're up in the mountains. There's not a lot of tree cover, not a lot of shade, so they can heat up quite rapidly. And it turns out they can explode if they get too hot. So we can monitor those tires live, predict when they're about to fail, and either shut down the truck remotely, slow it down remotely, or send it into the shop to get serviced. So yeah, I mean, that's just one of the very smallest projects that we're involved in right now. Eventually, we're going to produce a digital twin of the mine and have AI run huge aspects of it, or at least right now we're working on suggestion engines, and those suggestion engines might be action engines very, very shortly.
Excellent. Thank you very much, Jordan. Jamie.
Good morning, good afternoon, good evening, everyone. So I wanted to bridge off of Jordan's comments. You know, I got my start in smart machines and smart manufacturing at National Instruments, and mining was a key component of our customer base. And what we found in mining, as well as power generation, is the first artificial intelligence application that got deployed was predictive maintenance. Predictive maintenance is a great place to start, where you're acquiring data and using analytics to determine when things are going to fail and what their expected life will be. And then smart vision systems using artificial intelligence to optimize manufacturing is where things go from there. So I have a fairly long career in smart manufacturing, starting with National Instruments, where I led the industrial Internet of Things business there, and then moved on to driving their autonomous vehicle test business. And now I actually work in education technology, where we're taking camera systems and adding AI to do auto tracking systems, so instructors can teach in the classroom and bring remote students into the classroom without disrupting the way they teach, and without needing a director or someone to guide the camera and guide that content creation and video system. I'm very excited to be here and learn what our fellow panelists are thinking about and what's motivating them, what's challenging them, and to add the comments when appropriate. Thanks for having me.
Thank you very much. And last but certainly not least, Chitrai.
Good morning, everyone. This is Chitrai Mani. I'm from InfoVision. I'm a Chief Technology Innovation Officer, and I'm the CEO of Digit7 Labs. I'm currently heading 4 products from Digit7 Labs. Each one is focusing on multiple verticals, and some of the products are retail, some of the products on they're focusing on telecom, and some are on manufacturing. Are all of you able to hear me properly, or are you facing some issue?
We can hear you okay, but you're turned off.
Okay, I've disabled my video. So we are currently focusing on the products. Some of the products, as I mentioned, is a more computer vision based products. How to track the manufacturing environment, how the, for example, some of the cement manufacturing accounts we have been focusing on, how to track the end-to-end system, what is happening. The supply chain is the biggest problem in manufacturing industry, right? So there, how to bring computer vision-based solutions, and there we are building certain products of how to track the inventory information, where it's going, where they deposited, and where they are keeping it. The problem in the industry is whenever someone orders it, the local field people don't know how many in the local. There's a lot of gap in the inventory information from supply chain perspective. We want to automate it in a very fashion way using computer vision. Apart from that, we have been focusing on supportive product. For example, for computer vision, you need a lot of auto labeling, right? So tracking the products or person or any inventory item, you need to have a lot of training. We built the auto labeling or complete auto. For example, if you train a product, you need at least 5,000 images to auto label it, right? So instead of that, if you label it only 300 products, images, rest of the images is going to be automatically trained. That will be great, saving time for 2 days for training each and every product. So we developed a product on that side, how to automate the labeling of the computer vision also. So one of the area we are focusing is a multi-industry area focus. And we have built a cashierless store model. It's more kind of retail and manufacturing inventory, more kind of e-commerce business. So retail business and like Amazon Go model. And pretty much we are involving more AI, ML, demand forecast, predictive analytics side, how to bring more heat map information to the customer. So a lot of area we are focusing on this. Adding to that, it's a combination of technologies, not one technology of just ML or computer vision. It's a combination of IoT, or we use a layer technology. We use computer vision, digital twin, how to visualize, and AR, VR as well, how to solve the problem in the manufacturing industry using AR, VR. It's the next generation model. So we're combining the technology solving the problem in the manufacturing industry.
Excellent.
Thank you.
Thank you very much. So I would like to start the discussion with a little bit of a level setting open question for everybody. If you follow the news today, you may get maybe not the right idea of what AI actually is, or how can it impact our world and the industrial sector specifically today. So by reading the news, you may think that we'll be saluting our computer overlord soon, or or the Skynet is coming, and those things. And I want to set the level. So in your words, in 30 seconds or so, what is AI and what is it not? What does it represent to you and our industry at this time? And Jordan, would you like to start with that?
Thank you. One of my university profs once told me that AI is the science of things that don't work, which is funny because once they start working, they assume another name, right? So right now we have machine intelligence, machine learning, visual processing, et cetera. So typically we use machine learning, right? That's the revolution that's happening right now. We stood up our organization 2 years ago from 6 people, and now there's 500 folks working for us. And it's really difficult to get resources, right? Every startup out there wants a data scientist, right? Even if they don't quite know what data scientists do. Data engineers, same thing, right? So I would say that artificial intelligence is a very broad area. The folks on this call are probably more interested in machine learning, right? Which is function finding, So basically, it's understanding a way to generalize solutions to very difficult problems. So a human expert might be able to provide you with 3 solutions. A machine learning algorithm could provide you with a number of solutions that are very fuzzy in nature. So hopefully that kind of answers the question.
Right. And do you think that at this point, artificial intelligence is replacing, and now we're getting a little bit into the ethical discussion on AI, is replacing workers or is enabling workers to be more efficient? Is it an enabler or is it a replacer?
So in mining, we're very concerned with safety. So, moving workers outside of those trucks, right? Those haul trucks, they're dangerous, right? They can fall off a road. One of our pits in Kamloops is 1 kilometer deep. It's an inverted mountain. right? So, unfortunately, like those trucks can be dangerous. You take workers out of them, you make them safer, right? You get them out of the blast zone. We do a daily blast, right? Which is 80 tons of amphor. One ton of amphor was used to destroy the Edward P. Murrah building in the Oklahoma City bombing, to give you an idea of how much explosives are used every single day on a mine site. So getting workers out of there is important. And as responsible employers, we retrain those workers, right? So I saw it in a haul truck with one of our drivers on a site where half of our haul trucks were driven by robots, right? So they were driverless. And I asked her, I said, geez, you're working on the same site with the robots. Are you worried about your job? And she said, no, if it wasn't driving a haul truck, she would, be a shovel operator or run a drill or any number of other positions within a mine site. The fact of the matter is, in Canada at any rate, and I'm sure this is the same in the United States, we have a worker shortage, right? We don't have a surplus of workers. So as artificial intelligence does, we are taking over certain jobs, right? There are not going to be haul truck drivers in a year or two. Those workers will be retrained and put into other areas of the economy, right? And, while we have this worker shortage.
I think that's a really interesting point, Jordan. And just to build off of that, when I'm trying to explain the role of AI, analytics, machine learning within an organization or to the groups that I'm working with, I always really try to impress upon them that this is a complement to what you're doing. It might help you to do what you're doing with more value. Your job is going to change, but it's not about replacing you. There's an art and a science. The art is the interpretation. The art is the application. I think at some point, once we get into like the future state of AI, once we've really made that leap into the full artificial intelligence where the computer can learn, interpret, anticipate, then we might find ourselves in a bit of a different situation. But today, with the maturity level of AI and machine learning, it really is an opportunity to automate those things which, quite frankly, don't make your job that enjoyable. Those waterbird tasks that you do every day, the computer does them really well, possibly more reliable than a human, so that you're freed up to think more strategically, to do something a little bit more interesting, and to really exercise your brain.
It is more enabler from my point of view. It is more definitely is enabler than a replacer. That's what I'd like to call here.
So I want to point out though that like today we're building suggestion engines, right? That complement workers. In the future, we will be, absolutely. There will be some losses in even white collar jobs, right? Like with machine intelligence, it turns out that there are functions everywhere out there, and that humans often just operate on those functions. But that doesn't mean that jobs are going to go away. If you look at, I started my career in banking, right? And I would have clients come up to me and say, I'm dealing with you because I don't want an ATM, an automated teller machine, to replace you, right? Turns out there are more people in banking by a huge margin now than there were when automated tellers were introduced. Those people are just working more in the back office. They're working in cash transportation, et cetera, et cetera, et cetera. So they're doing different jobs, right? So in fact, there are fewer tellers now, but there are more branches, right? So instead of having just one big centralized branch with 16 tellers, you might have 4 very small branches with 5 tellers, right? So more net tellers, even though the ATMs were introduced.
Yeah, their jobs have evolved. That's exactly right.
So on this topic, then the next question, if we're seeing more AI being adopted and it's being implemented in certain specific types of tasks, how aware should we be in potential bias in those AI models? And what can we do about that? And Brandy, I don't know if you have an opinion or would like to take this one.
I think the bias is a really critical component to think about. Maybe not in the automation of the mining trucks, but even then, the bias of the person building the algorithms. If they have a blind spot when they're putting that together, they're not going to factor in all of the pieces of information necessary to make it as safe as they could. So there is a lot of learning, there's a lot of domain expertise, and there's a lot of creativity required in order to build an algorithm that's redundant, and even just being open to the possibility. And when we think about AI and the application of, let's say, hiring, I probably wouldn't get hired because, quite frankly, I'm not a person that generally fits the mold for a multitude of reasons. And if we can start to factor in that concept for minorities, for groups that wouldn't otherwise be represented, and have that top of mind when we're developing our algorithms, hiring diverse groups is going to allow you to have a more open perspective and making sure that you really challenge those models. And Jamie, you had an amazing talk about this when we first sat down to brainstorm on this. So I'd love to hear from you because you had a really great example. I think that really speaks to this.
Thanks, Brandy. Yeah, I think the bias is really in the data set that's used to train the model, right? So you have to make sure that you have a complete data set and enough pieces of data to handle all the use cases. One pretty well-known example from the autonomous vehicle space came from a team that did a lot of great work with camera systems identifying pedestrians, and they come from a cold weather state. And so they took their algorithms to a southern state, Florida, and began to use them, and they couldn't identify people because those camera systems had never seen a woman in a skirt or a person wearing shorts before. So they didn't know what they were looking at. And that's just one example. It's a pretty extreme example about how bias in the data can really influence the entire system in ways that even the developer putting the system together may not predict. So I think we need a level of oversight for sure on these systems. We don't want to just let them run until they've been established and proven. But bias is probably one of the biggest challenges that we're going to run into that's going to slow the rollout of these systems. I know we're talking about manufacturing here, but I think there's a lot of lessons to be learned in autonomous vehicles. People had goals for the autonomous vehicle space. There's an article I wrote that was, 2020, the year of the autonomous vehicle. Where are they? And it's up on my LinkedIn. You guys can take a look at it. But the issue that teams ran into is the world around us is an infinite space. It's an infinite data set. By definition, the analog world is infinite. And so covering all the use cases that a vehicle might see under all the conditions, all the weather conditions, all the reliability of camera conditions, all the conditions with traffic and so on, all the scenarios that a car might be in, it's an infinite test set. So getting to the point where we're confident that the algorithms will perform safely in the real world is very challenging. And with these systems, just like with human workers, there's going to be an element of risk. So when we roll these things out, we'll be taking risk. And it'll be up to leaders like us, the people on the panel, the colleagues at the panel, and the people here attending this conference. And hats off for you to coming and learning about these things. It'll be up to us to manage that risk and help organizations make the decision, yeah, it's time. It's time to deploy that autonomous hauling truck at the mining site, or it's time to implement AI in our applicant sorting algorithm. Because the last thing we want to do is treat people unfairly or cause damage to equipment or even lose a life.
Jamie, I agree about the biases in data. I want to point out that there could be biases in the wind condition. So machine intelligence is trained using a wind condition. And I'll give you an example of that. With our autonomous mining trucks, right, which feeds very well into the vehicle talk that you just had, they figured out the optimal path and they drove on that path. And what happened was you get huge ruts in the mines. They were destroying the roads, right, because they would drive exactly on the right path, right? Whereas human operators have, they skid and they take corners a little bit faster, et cetera. So human operators wore the roads evenly. The robots wore them in very specific places, right? So we actually, because the wind conditions said just drive in the best possible way. So we had to introduce jitter, right? So into the algorithms. We had to make it so that the trucks vary their path a little bit in order to save the roads.
That's like interesting, the law of unintended consequences, right? You get it just right and it's perfect, and then you learn something new about the process, and you have to really agilely respond to that and develop the methodology of influencing your AI to offset.
That's what the unsupervised learning is getting to picture, more unsupervised learning, how to improve more in agile fashion. That's what I think the gentleman presented before learn more, keep improving it autonomously. That's a major game is going on now.
Yes, excellent discussion. So, the presentations we've seen today, we've talked about other technologies that are impacting or are benefiting from the developments of AI, like the digital twin, for example. And you can add on top of that cloud computing, edge computing. So, Jamie, which technologies do you think are going to be influenced the most by the developments we are living through in artificial intelligence? Or which ones are the ones that are going to influence that development itself the most?
Yeah. That's a great question, and I'm gonna kind of answer it. Let's see how I do. So I think when we think of artificial intelligence, and I want to bridge to one of the questions that was submitted about how long will artificial intelligence be a thing? You know, is it going to be a thing for a while and then go away? A colleague of mine called artificial intelligence the new electricity. And if we look at gross domestic products of nations, one of the most highly correlated factor in GDP is the availability of reliable electricity. And so we have a hypothesis that artificial intelligence will enable and fuel economic and wellness growth across every industry. And we're just getting started. We're just chipping at the surface. We don't even understand all the applications, and probably never will, where artificial intelligence can be applied. If we think about where we are today and some of the challenges that we still need to work through, it's this issue of architecture. It's where will we do the learning? Where will we do the training? How will systems be deployed? Whether it's distributed systems or centralized systems. What's the role of the cloud? You know, these are complex issues that have pros and cons. And there isn't a right answer. For every application, there's going to be an optimized answer for today. But that answer may change over time. So today, you know, things like cybersecurity are going to be critical. Cloud computing, network reliability are all going to be critical. And we were talking about the role of 5G earlier in the call. I think in the factory, 5G, it's not going to be that critical, right? Because it's more of a contained, we'll call it technology ecosystem. But when you get out in the real world, 5G and additional wireless standards are going to be critical because we need reliable, deterministic wireless communication to coordinate systems. So I said a bunch of stuff that I believe in, but I'm not sure if I answered the question. So why don't we hand it off to someone else to see if they can try to put a bow on this one.
Just adding to the point, it's a great point, Jamie. Just adding to the point from my perspective, we have been focusing on a lot of 5G areas. Okay, so when you mentioned that AI, and especially on the networking, because the networking side intrusion is very much high. The problem in the networking direction is nowadays we have been working on one of the project how to bring network visibility in digital twin with the help of AI. We are combining these three together. The AI is going to be an important area based on the data, how to bring. But networking, when you talk about wireless, all the network, yes, it's a very critical. 5G is going to boom a lot. Every telecom industry is investing multi-billions on this 5G enablement. In 1 or 2 years, it's going to be very high. We are very close to working with telecom industries. And on top of it, I'm seeing that the network data with the AI/ML capability we are presenting in the digital twin is booming a lot in the area. So you can visualize the problem in very real time in the digital twin, especially the topic of digital twin. That's what we have been doing it currently. So that's going to change the game a lot. With the help of, it's not only digital twin, 2 different technology that AI is helping a lot. AR, VR, and digital twin. The combination of these 2 blending with AI/ML is the one promoting a lot in the industry now. It's a very valid point on the networking perspective.
And I think that to your point, it's really about the evolution, right? Like I don't think AI is going anywhere specifically. I think the AI we know today might become a little bit more obsolete as we move into more advanced technologies, as the space evolves. And it is evolving much more rapidly now. So we're on that like exponential growth curve. AI has been around for years, but it's really to your point, Jamie, and truthfully, it's the technological background to support it. It's the cloud computing. It's all of these other components that are contributing and allowing the ecosystem to really be rife for that evolution, that transformation, that disruption, even of the AI space.
One thing I'll pile on this topic.
Yeah, pile on.
one quick comment. There's two technology laws that are pretty well known. Moore's law, right? People are familiar with Moore's law, which is the doubling of processing performance over time. There's another law called Nielsen's law, which is the increasing rate of bandwidth of the network, and it is roughly a fifth as fast. Both of these, of course, are exponential growth, but Moore's law is a 5 times as large exponent. So it grows much, much more quickly than the network itself. So this whole idea that we're going to take all the data, put it in the cloud, crunch it, and push it back is foolish, right? What we need to do is take processing that's pretty cheap and put it out there at the edge. You know, if we use something like this, you guys probably seen one of these before. When we do AI with this thing, we don't know what's running on the phone and what's running in the cloud. Or if we're using I got one over here, the lady that starts with an A, that lady, when we ask that lady questions, we don't know what's going on in the device, the Echo device, or what's happening in cloud. And quite frankly, as consumers, we don't care. And I think that what we're going to see in the future is more and more decision processing will be happening at these edge devices, and even training will start happening at the edge devices.
Yeah, and I think that edge computing, and for the reasons that you mentioned, Jamie, is what's gonna blow up the lead on AI adoption, specifically around industrial applications, where communications can and usually are challenging still, even though there's progress being made, is not ubiquitous everywhere, right? So, and that's a big aspect that needs to be better understood by customers and organizations. So now let's turn a little bit. We talked about AI, what it is, what it's not, its potential, its other technologies. Let's say an organization out there is ready and say, you know what, I want to learn more about AI and how to implement it. What would be your advice to an organization on how to get started? And what are the do's and don'ts of adopting AI? And Brandy, would you like to take a stab at that?
Sure. I think one of the biggest hurdles to starting out with AI is I think some of our other speakers talked about is they don't even necessarily know specifically what data science is or what a data scientist does. So hiring just specifically a data scientist isn't often sufficient to get the full value. You need to understand data engineering. You need to understand where your data is. You need to have the tech in place to be able to support that. So in making sure that you have the right pieces in place to really support the full ecosystem so that you're not just developing POCs, which is another topic from earlier today, is those POCs, fascinating. Curiosities are amazing, but unless you're pulling it all the way through in a very practical way to implementation, it's going to fail. And when you think about it, there's a recent study done where 82% of organizations don't think they're getting the value from their AI investment. As an analytics professional, that's terrifying in one sense, because there's a ton of money going into this space. But on the other side, there's 18% that are, and it's because they're putting all of the pieces in place to support it. They have organizational buy-in, they're combining domain experts with scientists, with the data engineering and the tech teams, and they're pulling these multi-factored groups together to really pull these initiatives through to implementation. And that's where they get the value.
And how would you sell the project to an executive team, to a leadership team? Like, how would you position it in a way that is understandable and consumable at that level, and that they will say yes?
So I'll put a proposal out there that with all of these systems, you need data to train them. That's absolutely critical. And oftentimes the data needs to be associated with an outcome or some kind of result, because you need to train, hey, when you see this type of information, that tends to lead to this type of outcome. Right. So the first thing and the easiest thing to sell is start capturing the data. in an organized way. And once you start capturing the data, then in parallel, you can start prioritizing where the biggest challenges that we have within the organization. Is it a yield issue? Is it a people utilization issue? Where's our waste? And then focus on that problem. See if you can hypothesize a way to use the data you're collecting to address that problem. If you can't, figure out what data you need to collect. And I want to go back to Jonathan's talk from earlier. He said, you have cameras. I don't know if you guys remember that from the call. So to use the cameras you have, your factory has so many sensors out there implementing these machines. It blow your mind if you did an audit of it. So the thing is that most of the time that information isn't being brought into a centralized location where it can be used. It doesn't have to go to the cloud, but it should be brought into a centralized data center on premise. So you have the data in an organized way so you can start using that data.
I think it's the concept of data first, right? Like, how do you make sure that your organization believes in the value of data so that the people at the front line are entering it properly, they're storing it. It is an entire organization-wide problem. Data can't just be left to the tech teams to solve, because then you spend all of your time just munging through raw data that is not clean. And it takes so much longer to get to value as a result. I'm sorry, Chitra, I totally cut you off, so I want to pass it to you.
Yeah, that's fine. So your role is very important, Brandy, because if the chief data officer is not releasing the proper data to the company, you cannot build any of the stuff. Just adding to the point of how we have built it for the real-time customers, most of the customers ask for how really you want to start. As a POC of data is true, definitely no question about it, but identify the right use cases where you will see the ROI. So it's two different kind of stuff. Some of the people look for what is the forecast, what the sales is going on, and some of them look for, because in manufacturing there's a lot of areas that what is the movement of the data, inventory move, as well as process side, many things you can find out. But as a use case perspective, finding the right use case and belongs to that, creating a right data move is very, very important when you talk about the first POC level. What a lot of people are trying, hey, let me take something in machine learning, let me build something, show some hello world model, hey, how it is working. Or else they are thinking too much. Some other companies are thinking, oh, enabling innovation to the company is a big thing. For example, how to bring AI governance first, how to bring frameworks, all the stuff, regulation. No, you don't have to get into that level first. Start with simple level, as Jimmy and Brandy mentioned. So use case identification, simple data area where you want to go, which one is really pick up. Try to frame a small team, small kind of framework, small kind of testing team. Start with that, see the output. It will easily grow from there. So governance, regulation, privacy, ethics, there is a lot of data modeling. All this will come slowly next step. But identify use case is the first one.
So what I hear, data is the first step. Good data is the first step. How does that play with what we heard just a few years ago? The whole rage was big data. What does that mean for AI, if anything?
Wow.
I want to one of the most misunderstood concepts, because everybody thinks they have big data and some people don't. They have valuable data and it is big in importance, but it may not be large in actual scale in terms of what big data is.
Yeah, see, the transformation of big, I was in an era of both. I'm very core techie architect on both sides, handle a lot of big data project. The problem for the decade before was how to store the data, organize it properly, try to create the reports out of it, or processing it for transformation analytics side, right? That is one of the major problem. There is no proper tools or solutions available. That last one decade was going on, not last one decade, 2001 to 2010. It's pretty much focusing on big data solution. That's what industry was booming. When last 5 years, if you see, they have enough solution, enough kind of products available to store the data, how to organize it properly, well and good, because cloud matured a lot, but they don't know what to do with the data now. Okay, enough of data. That's what now it is transforming into more AI. Hey, because the cloud enablements helping the infrastructure, because the infrastructure is available, a lot of people are easily deploying machine learning model, everything. That's what the boom is happening now. So people are trying to leverage how to use this data to bring more forecast, more prediction, how to optimize more. That's what the trend is moving. Big data is still going to continue forever. There is no question. But how to use the data for using it? Maybe AI now, so tomorrow is going to be something else. In AI itself, multiple channels are there. So what are the other things going to use properly is the question. So we'll be using for multiple things in the future.
So one comment I'll put out there back on the prior question of getting started and this whole idea of resource limitations. So there's a lot of courses out there that are these executive education courses that are highly technical courses. The University of Texas offers one, the Macomb School. It's a great one. It's online. But there's a bunch out there. These things take about 15 hours a week. They're pretty intensive. The UT one is 6 months, about 15 hours a week. And if you have people that are leaders within your organization, at the top, but people that are director level people, are senior managers under them, go out and take these courses so you have a real strong understanding of what artificial intelligence really is, how it's implemented. It's not that big of an investment to make to really start to understand how to reshape your organization. It's a heck of a lot cheaper than hiring a consulting firm to come in and build a plan for you that we'll just say may or may not work for your organization. So that's something to think about that's pretty pragmatic that you could maybe pitch to your boss. And if you Google artificial intelligence, University of Texas, Macombs, that's one example. I'm sure there's others out there, and maybe in the chat people could put some other examples of things they're aware of.
Yeah, I'm thinking just building on that, like easy steps to get started. There's a lot of technology or a lot of technological advancement around low code and no code development in AI machine learning. And I think that is one of the most exciting things. I know one of my colleagues is actually in the audience today, and he's developed an amazing application that allows you to build microservices that take all of the technological responsibility or the extreme amount of technological understanding and expertise out so that you can actually get your hands on the code. You can get those domain experts moving. I know Jonathan talked about it. And I think it is one of the most exciting opportunities to democratize not only data, we talk about that a lot in the space of data and analytics, but it's also democratizing access to the analytical capability, to the power, so that you can start to develop those POCs much more cheaply and using technology that has the wrapper so that you don't have to develop your entire data science architecture in order to support it. So I know that's one of those ones that's really exciting. That's brain toy for Kwame.
Adding one question from my side quickly to all of you as well. So a lot of companies looking for how AI is going to help your ROI. It's like a lot of people have a question. Am I investing unnecessarily in the AI, or it's really worth it? I would like to see your views as well, all of you. Please take it.
Anyone wants to take that one? Jamie?
Could you repeat it? It kind of broke up a little bit for me. What was the question?
So how ROI, how is that the AI investment, how it is mapped with ROI? It is really worth the ROI mapping.
Yeah, I would turn around and say, how is lean in your manufacturing system or Six Sigma? What's the ROI there? How do you measure ROI there? And I would say they go, well, we have confidence in it. We believe in it. That's the way I would try to twist the conversation and say, this is really an augmented way to do things like Six Sigma and lean, where you're really going to create an augmented process to improve the overall performance of the manufacturing system. And let's not focus on the ROI, because we're not going to boil the ocean here. We're not going to do everything at once. Let's try to solve a problem. And when we look back and we say, did we solve the problem and are we happy with the result? They'll go, yes. And then you can say, did it cost too much? And they might go, yes. And then we can say, well, let's look at the next one and see if we can do it more efficiently. Right? Should we do that? And if they say, no, it didn't cost too much, then the dam bursts, man. And you're just going after these problems one at a time. So I would make it more about the return and less about the investment.
I think it's important to note that you can develop baseline metrics as well, right? Like all the data that you have that you're going to be feeding into your AI and your machine learning algorithms, you can set a baseline and then you can track and report consistently back to your executive team so that they can consistently have that benefit reinforced. And once you have the momentum, to your point, Jamie, the dam does burst. You get one or two of these projects through and people start to see the value, and all of a sudden their minds just explode with the possibility. And you have this opportunity to drive it throughout the entire organization. And eventually you're just so busy you can't keep up. But that's a good problem to have.
Yeah. What I would add to that is when I talk to customers around the possibilities, the options, and how to introduce these type of solutions, it's really not a problem of trying to find use cases. Use cases are plenty. The real question that needs to be answered is, why would you pick that one? What's the business value that's going to be delivered? It shouldn't be just a technology validation project. It should be a business value delivery project. And then apply the principle of, start small, prove the value, and then scale fast. To the points that were presented in the previous discussions as well.
The image of the hammer on the screw comes to mind for me from the last presentation, which I just was like, that is so perfect. You got to find the right tool to fix the right problem. So sometimes you can build something really lightweight that gets you the value and you don't need to over-science it. Sometimes you do need the full scientific approach with an absolutely perfect algorithm because really you're dealing with lives. So it's really about choosing the right path for each of the problems.
Right.
Yeah, and I totally agree with that. These are great comments. The other thing is don't outsource it. I mean, you just outsource it a little, but your people know your processes better than any external company, no matter what they say. No offense to anybody on the call or the panel or in here. It's got to be a partnership with the team because they also have to own it. You know what? Once it's rolled out, they've got to buy in and not be looking for ways to discredit it after the fact.
The point is own center of excellence team in this area is important to have because it is not like other application. It is very different in AI areas.
Yeah, and I think that's one of the changes that I've seen, again, coming from a vendor that are the most impactful to the market is that it's not longer possible to just build something and sell it. I don't think that's effective anymore. It has to be a co-development, co-innovation together, a partnership truly with the customer, right? So we can bring in the expertise from and experience from technology and maybe other customers. But Jamie, to your point, the customer knows the process best. And there's no replacement to that. And they have to be part of the solution or it will not work.
Yeah, please go ahead.
No.
There's a question, Helenio, in the chat box. I'm not sure whether it has been seen or not. Nowadays, due to Industry 4.0, traditional manufacturing practices is going down. As panelists, what is your views? Will AI stay longer sometime or some other technology will take over it? Charu has asked the question.
Yeah.
See,
I think
I can take it starting with what I'm seeing in the industry. It is not tech. AI is one of the technology. Think of AI is not. It's artificial intelligence has a multiple flavor underneath. Okay, if you call RPA, IPA, we used to call even machine learning, deep learning. There is a lot of variation underneath in AI. It is not going to take over by some other technology, but it is going to blend with other upcoming technology. That is what is going to be. Because more it's prediction, it's going to needed by artificial side. So definitely it's going to blend with other technology. In future, it may be more AR, VR. I'm seeing digital twin. These are the areas going to boom a lot. So it will blend with. It's not going to replace it. How data is blending with AI now, how AI is going to blend with other technology is going to be evolving. It's evolving is the right word, and it's going to blend with other technology too.
And I think drawing on Jamie's earlier metaphor around electricity and how AI is the new electricity. Electricity has powered so many more developments, and we can't even at this point in time really imagine the future state, but AI will be the catalyst. It will be a key component of those future technologies. So that's kind of how I'm thinking about it, is it's a stepping stone to the future.
And I think that's a great segue to our last question, which is, now, I guess, bring out your little crystal ball and let's say, where do you see the, you actually have one, huh?
Right.
Jimmy has brought down.
Where do you see the evolution of artificial intelligence in the short, medium, and long term? Where are we going? Jimmy, would you like to start?
I'm booting my crystal ball, so maybe take this one.
The Google crystal ball.
It's running an iOS thing. It's trying to boot here. Well, it'll be up in a minute. So
you want to take it?
I'll dive in and just make a comment. So if we think about artificial intelligence, we're just getting started. We're seeing a lot of success with artificial intelligence in the consumer space, right? AI is pretty prevalent in and around our homes and with our smartphones. We're going to continue to see those types of applications. Those applications have one thing in common. None of them are mission critical. If you ask your assistant what your meeting is for today and they say, I don't understand what you're asking me, it's like nothing really bad is going to occur other than your partner that's maybe a little technology averse will laugh at you, right? That's probably the worst outcome. But when we get into things that are more mission critical, these systems have to be more robust and reliable. So the simpler AI systems that we can trust how robust and reliable they are, they will get deployed in mission critical applications. They'll become broader, and we'll get into this area of big data and bringing in data from multiple industries to make decisions, traffic patterns, weather, the price of corn, all these other things will be factored in, and people will make other mission critical decisions when these systems become robust and reliable. So it's going to be an evolution. It's going to take time, and we'll still be early, probably for the next 20 years.
It is evolving. Same AI from my perspective. AI adaptation is happening now. So people started adapting. So the adaptation happens, then automatically the technology will evolve. So that I'm seeing a lot of industries, customer. Even it maybe you are using maybe 5 devices with the AI intelligence with you, right? So watch, it may be phone, it may be some kind of many devices we are using nowadays with AI. People are adapting that. It keep increase it will keep evolve. But as Jamie mentioned, are we matured enough to say it's very accurate? No, we are not. We cannot 100% trust at this moment. But we are seeing that because of the infrastructure support from big players, as well as a lot of companies are investing on improving on the side, I see it's evolving. Definitely, from my view, next 10 years, a lot of technology companies going to focus on enabling it for the people. But unfortunately, or fortunately, I don't know what to call this. Tesla CEO, Mr. Elon Musk, mentioned that no automation. He hates automation. I don't know how many of you know that. That surprisingly, it's going to be threat to the human. That's it's create a contradictory statement about what we are talking about now. Because he's the one who made the Tesla car with his completely autonomous, using a lot of machine learning, artificial enablement. But it's a reverse topic. But definitely, I see it's evolving.
I think it's interesting because you're going to see this battle between trust and resistance emerging as we go through this, and you see it in the media. You see all of these big splashy news stories about where it's failed. So it is really upon all of us as leaders to help to really ground people in what it is capable of today, and that it's not perfect. We're working towards perfection. I know one of our speakers earlier, don't let perfection be the enemy of practice. You got to get moving. You got to progress through the implementation. So we all have to build that trust. And I think the next 5 to 10 years are going to be really instrumental in ensuring that we are able to establish a strong foundation of trust across all of the business leaders as well as throughout the entire organization. And with that trust, it's going to underpin the opportunities for the future. And if we can't build partnerships with our domain experts, with people that are actually on the ground doing the work, it isn't going to be, we aren't going to be able to reach the pinnacle of what's possible. We're not going to be able to really reach into that. So I think there's going to be some technological advancements, obviously. I think we're moving into deep learning. We're starting to build the capability that will lay the foundation for our autonomous machines to even feel at some point in the next 20, 30 years. I think that there's a lot of runway and we're moving really quickly, but trust is critical. So we got to be really meaningful. We got to really be conscientious about what we're putting into the market. And then I think the white box Deepak talked about earlier today is really important. So if people understand, if there's transparency behind what's driving the algorithms, people are going to trust it that much more. So we have to make sure that there's opportunities for people to understand why the machine is making the decisions it's making so that we can intervene when it's going off course so that we can maintain the course.
Yeah, from 20 years now, I'm expecting a lot of panelists is going to be robos. Okay.
Robo panelists.
Answer the questions more consistently.
Those panelists are calling me on my cell phone and asking me questions about my car warranty.
Mm-hmm. Yeah, and then you answer and they're like, I don't understand. And you're like, I don't know how to ask.
Excellent. Thank you very much, everybody. I think the discussion has been very good. I think what we've said is AI, first of all, is here to stay. AI is going to transform our industry, but we're at I wouldn't say at the beginning, but we're still in the initial phases of adoption and evolution, and more is to come for sure. So I just wanted to quickly thank everybody. Brandy, thank you very much. Jamie, and Jordan as well, who had to leave us a little bit early. But thank you very much for the discussion. And Nitin, thank you very much for organizing this panel discussion.
Thank you, everyone. I think it was a lovely panel discussion with a lot of thought process from everyone. I think I enjoyed it. It's a free flow discussion, and thanks to Chitrai, Helenio for moderating, and Brandy, Jamie, and Jordan just left for giving a lovely thought process to it. See you all in the coming months as well with us, associated with us, and we'll have a long-term partnership as well. Thank you.
Thank you.
Thank you very much.
Thank you.
Very much. Bye.
Bye. Take care, everyone.
Bye.
Bye. So, guys, we are on time, and Jim is waiting for us. Jim, are you there?
I am here. Can you hear me?
Oh, great. Yes, absolutely. Thank you, Jim. Thank you for patiently listening to everyone. And you must have a lovely enjoyment with all the panel members for 1 hour. So
yeah, well, absolutely. Absolutely. I have to say, after seeing the presentations I've seen already and listening to the panel discussion, I'm really glad that I didn't go first, because I feel like that's been an excellent buildup. You guys have talked about everything. You've talked about the key benefits of AI, where it's used in manufacturing, the evolution, everything's been talked about. And I think that leads in perfectly for me just to absolutely jump into an example and show you some cool examples that we have been successful with using AI in industry. Okay, so
please.
Yeah, so perfect. Can you see that okay and hear me okay?
Yes, absolutely.
Awesome. Okay. Hey, so just again, thanks for the introduction. My name is Jim Wilmot. I work at Siemens in Atlanta, and I manage a marketing team. We handle all the Somatic products that also includes AI. So we all do a lot of promotion for PLCs and software I/O, AI. So today I want to give you a little presentation on optimizing manufacturing with artificial intelligence. And like I said before, I'm specifically going to focus on some examples. So thankfully, you guys have covered the background for me, so that's perfect. And I'm going to focus in the areas of quality control and robotics in this presentation. And specifically with quality control, this is basically watching the process, monitoring the process ahead of time as it runs, and trying to do a predictive maintenance for what the outcome might be in a certain way. And as was mentioned before in the panel discussion, AI is kind of a complement here in what I'm going to show. You're going to see existing applications that are running that we're actually going to improve using AI. So that's kind of what you're going to see within this quality control section. So let me jump in and start with a perfect example. This is a printed circuit board cutting machine. And this is an example that's working in our Amberg plant in Germany, and it's cutting circuit boards for us there. And to give you a little background of the whole thing and what the problem was, so this is actually a PCB cutting machine. It has a bunch of spindles. So 18 different spindles are cutting out these boards. So the blank green board goes in, as you've seen, and this machine cuts all the little tracks, it drills the holes, it gets it ready for soldering in the next process. Okay, the problem that we have with this machine is as it's cutting these boards, the green dust that comes off these boards is extremely aggressive, and it gets into the oils and into the bearings, and it stops the machine. So you have 18 spindles, and anytime between 1 month and 6 months, the machine will stop. And really, you have no indication of when that's going to happen, and it's causing a lot of unplanned downtime. It stops in the middle of the night. It costs shifts to go down. You have to bring in special people and pay them overtime to come in the middle of the night to fix it. It's very expensive. So this was a big problem we had with this machine. So what we tried to do was implement some AI, not to fix that problem. I mean, the dust is going to take the machine down one way or another, regardless there's AI or not. But what we tried to do, and our goal was to be able to predict when that machine was going to go down so that we could make a planned downtime. So we didn't have this unplanned downtime and machine damage and PCB board damage, things like this. So that was the goal of this particular project. So again, I'll just show you a big picture overview of what we did here. And again, there's 18 spindles. This is a machine that's already running. So the good thing about AI and adding AI these days, and you've heard this mentioned a million times before, we don't have to dig into the actual machine code. Okay, that's already running. We don't want to mess with it. We don't want to change the loading. We can add AI using an edge device. And that's exactly what we did here. So it's kind of a separate system. And in this case, the edge device was an IPC, a very powerful IPC. And you're going to see when I talk about AI and the other things that I show, that we can do AI in a lot of different areas. It is not like it's not a cookie cutter, one size fits all. You can do this AI in an edge device. You can do it in the cloud. You can do it in a special card that works in the PLC level. Depends on your application. So very, very flexible. So the first step here was to actually collect the data from the machine. So we set up this edge device and we did all the data collection that we needed to do. And this is motor currents, motor speeds, temperatures, all kinds of stuff, right? So we collected all this data and we actually ran the AI algorithms on this IPC. So what is it actually doing? We're running it, we're training it. What is it actually looking at? Let me show you a couple things. First of all, it's doing a trend analysis. So it's looking at motor current versus time, and it's looking for that trend. It's looking for a rising trend, because if your motor current is going up over time, it's kind of an indication that there's some friction there, it's being clogged down, something might be happening with that dust, something not good. So that's one thing we looked at. The other thing we looked at was it's an anomaly detection. We're looking at motor current versus speed. So you can see there's kind of a normal operation range that we look for things to be in. And then there's also these red anomaly points you see on this little chart. Things fall out of that range and you start to question, okay, is something going wrong? What's happening? So we used that with the AI. We ran that algorithm, we trained it. We actually did the training on the IPC also. Important to note where we did the training because that can be different places. We did it on the IPC, and then we sent those scores up into the cloud. Okay, and why did we do that? Well, the main reason for sending it into the cloud was because we had a couple of apps there in the cloud that were running called Advanced Analytics and Performance Insight. Basically what they did was they took those anomaly scores from the IPC and they converted it into something the operator could use to make a decision of when to plan maintenance. So more specifically, the advanced analytics basically took that score and predicted the amount of time that we'd have before it crashed, so we could actually plan a downtime. And the performance insight, as you can see on the bottom of the page there, created a really nice dashboard for the operator. So the operator can actually see this, and he can see exactly when the spindle is going to go down. And I think they had it set up to anything greater than a 0.5 on the anomaly scale. You better set something up. So they could set up the maintenance and actually plan that downtime. So this was a huge advantage for people to know when this is going to happen, and it nearly eliminated the downtimes from unplanned crashes and problems with spindles. And to give you a little bit of results, this is the results I was given, is about $180,000 or euros per year we saved in loss of production. So this is anything from the loss of production, the extra shifts, the damaged equipment from the machine, the PCB boards lost, the premium overtime we had to pay to get people to come in the middle of the night to fix machines. It's a huge, it adds up. When you have 18 spindles, they had about $12,000 per spindles of savings. So a pretty big deal, actually. And if you look at the other figures below here for the transport unit and the box handler, these are systems around this other system, around the milling spindle and that whole system. Obviously, everything's a process in a sequence. So when that had downtime, not prepared downtime, you actually had problems and bottlenecks in those other systems as well. So we had some savings there as well. So a pretty big savings. You can see how it optimized actually in this case. So let me jump into a different example. And this is maybe a little bit downstream. So once the PCB board is actually cut and it's all ready to be soldered, this next machine I'm going to show you actually does that soldering and puts the stuff, makes all the solder points on the actual board. And the problem here is the X-ray. Let me again give you a description of the overall here. So first of all, this is a PCB board again. This is putting the solder points on it. And it's for one of our IOs, one of our distributed IOs. It's in the same Amberg plant. And what the problem is here is that once the board runs through the entire machine, every single board has to be inspected by an X-ray. Okay, and this is actually done by a human, right? It goes through the X-ray and it comes up with a little picture like you see on the screen. This is kind of tiny, but there's actually an X-ray that pops up that looks like this. And an operator has to stand there and try to identify problems. If there was a bad solder or something like this, and that's extremely difficult to do. Imagine the human error that could be intervened here trying to do that with one person looking at that and the monotony of that job. It's horrible. But it also was a huge, huge bottleneck, the time spent for every board to go through this machine. So the idea of adding AI, and again, not to tinker with the actual machine, but to add AI separately, was to actually eliminate sending some of these through the X-ray. So if we could have a model that actually showed, hey, this board looks to be 100%, I don't see a reason to send it through the X-ray, and we can bypass the X-ray on some of those, we could save a lot of time. So that's kind of the idea. That's what we tried to do here in this case. And again, to show you the bigger picture here, you can see the machine. You can see actually the circuit board. So this is kind of the cut circuit board going in, and the soldered up board comes out of the machine, and then everything goes through the X-ray. That's how we were operating for a while, but it's causing a big bottleneck with this X-ray. Okay, so the first thing we did to add the AI, very similar to before, we took a very powerful IPC and we added this. This is an edge device. Okay, we added it at the site and we collected data. And in this case, it's a lot more than the spindle cutting that I showed you. This data is in excess of 40,000 pieces of data. I mean, this is motor temperatures and currents and vibrations and anything you can name is put into this algorithm. And the funny thing here that's different is the IPC edge device is not actually running, it's not doing the training. It's not taking this information and training the algorithm. The algorithm with that much data, we actually needed to put that into the cloud to train it. So that was a little too much for the IPC itself. So we actually sent it up into the cloud because up there we have lots more computational power to train these huge algorithms. So the training was done in the cloud, and then once it's trained in the cloud, it was actually put on the edge device, and it actually ran on the edge device. So when the machine's running, it's actually on the edge device, and the cloud work is done here. Okay. So obviously we did a lot of training with this and a lot of testing to make sure the outcome was correct. And eventually we were able to connect it up to the MES system and actually make that decision of does the board go through the X-ray or does it not go through the X-ray? And this is a pretty dramatic decrease in work because at the end of the day, we were able to save about 30%. That means 30% of the boards were able to bypass the X-ray and go straight to the next processing point. So that's a really big deal. And the quality rate of what was let through was, okay, we say 100%. I'm also an engineer. I never believe when I say 100%, but very close to 100% is that what went through really, what passed through were no flaws. Okay, now there were a lot of boards obviously that went through the X-ray that came out perfectly fine, but the goal was just to eliminate some of these. So we tried to knock down the amount that was done, and that was very much accomplished. Also, we were able to eliminate one X-ray because there were multiple X-rays here, and now we don't need the multiple X-rays. So we came down to one X-ray and eliminated about $500,000 there. So a really big advantage to using AI in this application. So I think a good example too. I hope you guys have seen similar processes as well, but I thought I'd point that one out. I thought that was pretty cool how we applied that. The next area I want to talk about is robotics. So this is a really interesting area too. One of the big areas in robotics is with using AI, you can actually pick up objects in different positions. They don't have to be in a specific position. Using very low-cost cameras, you can actually take a look at this object and figure out a grasping point. And let me show you a quick video on grasping point and just walk through how this works if you haven't seen this before. You can see the camera on top of this robot is a pretty inexpensive camera. I think that's the Intel Sense or RealSense camera, I think by Intel. Basically, it takes a look at the object it wants to pick up, and it can determine then what are all the grasping points it has as options to pick this up. And we have a lot of demos here at Siemens that we show that use this technology. It really works and it's really cool. And this is one of the main benefits when you use AI within robotics. As you can see, it's also picked off 3 spots here, and it runs through the neural net, runs the calculation to see what the probability of success is going to be. So the first one it comes up with is pretty low. The second one it comes up with is a little bit better. And you're going to see as it runs through this, it comes up with one that's pretty high probability, and it decides to go with that. So this is a really nice thing. You don't have to program all this stuff. The AI algorithm is figuring out the best way to pick up this object and the most success. And we've got several demos running on this using both IPCs and special little card level processors. It's a really cool way to apply AI within robotics. And so I want to show you, that kind of leads into the example I want to show you a little bit. This is specifically good in the CPG industry. So consumer packaged goods. You know, when we actually sell things today, everything's got to have a variety, and things are changing continually. So if you just look at the screen here, you can kind of get an idea. I think the girl in this picture is pretty specific on what she wants. So apparently she likes pink. So a lot of consumers have very specific needs. And if you want to be successful selling, you have to meet those needs. And that means you have to change your line very quickly to personalize things. Names on Coke cans, things like what you see in this picture. And CPG industry is somewhere where AI is really proving to be very efficient. And I want to show you an example here. This is a really cool thing. This is a project we did together with another company called Klustermans. It was a co-creation project. And earlier in the panelist discussion, somebody mentioned there's a lot of this co-creation going on. For sure it is. I mean, AI is an open field. It's very, very flexible as to how you do it. So this project in particular was a 90-day challenge. So what I'm showing you here all happened within 3-month span. And so it's pretty impressive the rate that we got this up and running and working, what you're going to see. And I'm only showing you a small part of this video. This video goes on for 10 minutes without break. And I wish I could show the whole thing, but I'm only going to show a few clips of it. Keep in mind, too, when I say 90 days or 3 months, we didn't start from a blank piece of paper at that point. Okay, we had a lot of AI libraries built up that we applied to this machine, which I think is also very exciting moving forward, because one of the problems today with AI is that you don't have to be, I'm not going to say a PhD in AI to use AI, but you do have to have quite a bit of knowledge in AI to make things really work realistically. And I think the holy grail moving forward is for the average programmer, the average guy who programs a PLC or a machine, to be able to take some libraries and apply it and make it work without having a PhD in AI. That's the holy grail, I think. And we will get there, I think. It's going to be a little while. But let me show you what we did accomplish. And I'm going to show you this raw footage running. I hope you can hear my voice over the machine. It's not that loud, but I'll explain what's happening here a little bit. Let me start this up. So this is the machine, and you can see there's 2 robots, and they have a very simple suction cup on the bottom. And what we're packaging here is a little blister pack for shaving. So there's shaving cream, there's aftershave, there's razors, there's the razor blades. And right now it's starting off with something really simple, starting off with the aftershave. So you can see the AI is using AI this whole time. But it's a very simple thing right now. It can take a quick look at the actual lotion. It can very quickly see it's in the right position. The label is up. I don't need to use the other robot at all. I can just put this into the case and no problem. So keep in mind, this is AI. So it's a task that's been programmed here. So what we do, if we want to move to the next product that goes in here, He simply changes it on the HMI and says, hey, now I want the shaving cream, not the aftershave. So he puts it into the HMI, and it's the same. The robots are doing the same thing. It's just a different object they're looking for. And notice the way he sets that on the table. He just throws it on the table. He rolls the stuff around. It doesn't matter what's facing up, where it is. The robot will find that using vision equipment, very inexpensive vision equipment. Okay, this is the same camera that I showed you earlier, the RealSense. And what it has to do is it has to take this shaving cream and it has to put it in this cart with the label up. Okay, so it finds it. If it can do it with just one robot, it'll do it. But this next one it picks up, the label's not up. So it really has to use the other robot to find the top of the bottle and put it in the blister pack correctly. So it can use either 0 handoff, 1 handoff, or 2 handoff, and it makes that decision. So it doesn't matter really where the guy throws it on the table or what position it's rolled into, the robot can do that. That's really cool. And like I said, I skipped a little bit here. There were several things in there also that I could have showed you. It was very similar to what I already showed. What they did in between the last segment I showed you and now is they actually changed the suction cup to a smaller suction cup. It's a little white suction cup now on the robot because it's a different item. They're picking up these razors. And notice how it puts it in the blister pack. This is the same task that was being done with the other objects. It's just a different object. So it really, the amount of programming to do this is significantly less. And imagine if you changed your product moving forward, you could very, very easily adapt another product to this and use the same task. It's already programmed and done. So that's the big advantage in the CPG world using AI. And again, this is what you're seeing here is it's just like footage from a test scene. They're playing around with this, getting it to work. You can see now it's moving on to the razor blades. And all the guy did was tell it, hey, now you got to pack the razor blades. So this robot is just go ahead and doing that. It's the same exact thing it was doing before. You can see if it needs the other robot grabs it and helps out. So this is a pretty cool application that happens in the CPG world. Now imagine how fast you could change your products if you needed to in that case. So that's a really unique application. And again, note that that was 3 months. And again, like I said, I'm not going to say we started with a blank page and we didn't have all the king's horses and all the king's men, but we did have some of the smartest king's horses and men on that. So that did help. But you can see how this can be effective using the CPG machine. It's incredible because anybody who wants to be successful in market today is going to have to react to market changes quickly. Is going to have to offer these different products. We all shop on Amazon. We expect to order something and expect it customized and expect it at our house in 2 days. So that's kind of the mentality we're working toward in this environment. And this is exactly where AI is perfect in this industry. So those are a couple of really cool applications I wanted to show you. And sorry I had to kind of race through that and I cut some of the information out, but that was quality control and robotics. Like we said before in the previous panel discussions and the presentations, there's a lot of applications for AI. I have a lot of great applications in automatic sorting and visual inspection, all these areas you see on the screen. It's all over the board. So I just wanted to touch on a couple of them that I thought maybe you'd be interested to see. And I hope that was valuable and I hope you enjoyed that. And look forward to doing more AI in the future. So that's kind of what I had in those examples. And I think my time's about up.
Yeah. Thank you, Jim. Thank you for the lovely demo. Yeah.
No problem.
It's great that I'm seeing it for the second time.
Yeah. A little more detail, maybe.
A little more detail, yeah, absolutely. And I hope the audience also enjoyed it along with the other speakers as well. Thank you for giving such a lovely one.
Oh, thank you. Appreciate it.
Yeah. Guys, any questions for Jim? Like I mentioned earlier, you can obviously type in the Q&A section and the speakers will be happy to help you out. So we'll wait for 1 minute. If no question is there, we'll move on to our last presentation for the day.
Okay, and if there's no questions, if anybody has something later, obviously find me on LinkedIn. You can always ask these questions. Like I said, me and my team, we love to promote these latest technologies. So we love to hear your questions. And we have a lot of pilots going on right now with AI across the country with some of our new equipment. It's a very interesting topic. And again, I really appreciate the presentations before this. That was a spot on, great lead in to exactly what I wanted to show. And now I don't feel like I cut it too short because I didn't need to repeat that. Perfect.
Great, Jim. Yeah, I'd love to connect with you again, Jim, to understand more on what do you do. And I think you have a lovely products and demos to show. Maybe I missed that because the time was less. So
yeah, it's all right.
Great. Thank you, Jim, for the lovely presentation. See you very soon.
Okay, thank you. Appreciate it. See you.
Have a lovely weekend. Take care. So guys, I will quickly move on to our last presentation for the day, which is by Dr. Yen Chai Shang, founder and CEO of Mata Inventive. His topic is fusing artificial intelligence with equipment monitoring for mining optimization. Over to you, Yen, please. Thank you.
All right. Thanks, Nitin, and thanks for the opportunity. And I just want to say a few what Jim was saying, that a lot of the panelists have mentioned some really great points so far already. And so let me share the screen with you guys. Let's see.
Yeah, we can see that. You just have to make it screen presentation mode something. Yeah.
Right. Let's go to the first.
You had 53 slides.
No. A lot of it is just for animation purposes. Yeah.
Okay. Great.
Yeah.
Great. No issues. Yeah. Please.
Yeah.
Thank you.
Yeah. So what we want to talk about is the manufacturing sector and how AI can be applied to some of the important topics. And I want to reference some of the things that Jamie and other panelists have said, which is the how AI is always being asked to what is AI, and also how do we get people involved? How do we fight some manufacturing operations resistance to the adoption of AI? So we'll touch base on that, and especially addressing some of the key issues that happens on the shop floor, and follow that up with some of the really interesting examples we have by collaborating with some of our partnering machine shops. So first, I want to address that the main topic of what we're going to talk about today is how Mata Inventive uses AI to address profitability, efficiency issues on some commonly faced challenges that manufacturing facility management that has to face. One is to the first and the most important thing is to for a lot of management, what they have to do is to give competitive quotes. So when a client asks you, can you give me a good price, a better price, you have to make it low enough to make that quote competitive and appealing to the clients you're trying to obtain. But also you have your, you have to buy yourself lunch, right? So how do you make your shop or facilities to stay profitable, but while still being able to maintain a competitive quote? And once we've done that, done the calculation to make sure that that's the kind of price we can accept with a reasonable profit margin that you have in mind. The next thing you have to do is to schedule that job into your pipeline and make sure they run effectively. And the third thing is that we all know that nothing is perfect, especially that's why AI is useful. In this case, it's sometimes things can happen, like materials can come short, and also a machine can have breakdown, and some people can take a sick leave. In this case, in this environment, we've seen that an entire shop floor shut down because some operators got COVID, right? So bottlenecks is definitely something can be needs to be addressed as quickly as possible, because if not, then you lose your profit margin and you lose your on-time delivery, which eventually lose your credibility, right? And the most important thing is that once you know the bottleneck has happened, how do we stop that from really affecting the profit margin you have in mind and address that right in time before it's too late? And now with the help of AI is to how to address that even before it happens. And like I said, like the previously mentioned already, is that so some of the upcoming or has emerged challenges that we're facing right now after COVID is the increased shipping costs. We've seen our partners complaining to us is that shipping costs is like 5 times more now. So how do we use AI to address that? That's an important topic as well. And also labor shortage. We've heard complaints is that there are some shop floor operators refuse to come back to the workforce just because, you know, staying at home and collecting unemployment seems to be a better choice, right? So if that happens, what do you have to do? So here we list like 5 common categories of the manufacturing sectors that we have success collaborating with, but obviously it can be used for even more categories. But we found a good success of to combine machine monitoring with AI for additive manufacturing, CNC machining, and semiconductor and injection molding, and forging machinery. So for those previously mentioned issues that we commonly face on the shop floor, they can be managed actually manually when the facility is not as big, when the business is just starting up, right? Then like a lot of times as an owner or manager, we can solve that problems quick enough and timely enough, like if you can just look over everyone's shoulder, right? But that kind of stops working when the facility has grown to a certain level, right? And when that happens, what happens when that cannot be addressed manually in time? You have wasted time because you know it's your machines will stay idle, and you have wasted money because you still have to pay your employees. Just because the machine's idle doesn't mean that people stop requiring salary. And the worst thing is that you lose the productivity. Because if your spindle is not, like, this is a quote from one of our clients, is that if your spindle is not running, then we cannot charge for anything. So no matter what we use, machine monitoring, AI, all we want is to make sure our machine is always on. And definitely 2021 is not the first year where we start to solve those problems, right? And it's not the first year where people try to automate some of these processes through automation, AI, or monitoring, right? And there are some typical reasons, like previously mentioned, like 72% of people are not happy with their AI investment, right? And I think that there's similar stats for automation and machine monitoring as well. And there are some typical reasons that these things just fail. And one is that the machine monitoring solutions that a facility has chosen is not compatible with all of their equipment. And that's creating a huge problem. And the reason being is that if you're only able to monitor like 40% of your equipment, and the other 60 is either not compatible or too legacy, you just can't monitor it. You just can't monitor it. If that's the case, then you're only monitoring 40% of your shop floor. Then that's not telling you the full story. And also on the software end, that's an important issue as well, is that I think for everyone that's in the manufacturing world, is that can sort of like relate to this problem, which is that unless you work for a big company that builds everything in-house, most likely we have some kind of a experience with having to use multiple software pieces. And they're really good at doing what they promise and what they can deliver. For example, coding software is really good at coding, giving a code. And ERP software is really good at managing your whole schedule and attendance, for example. And MES is really good at reporting. QA software is really good at feeding back the QA results. But industrial software world is really fragmented, that those softwares don't talk to each other well enough. So as an owner or as a manager, we're not seeing the full picture. So that's one of the big reasons some of the automation failed. And the second is a really interesting topic is that, so right now, a popular standard for machine monitoring is Empty Connect. And we've seen equipment manufacturers that provide native Empty Connect support that just don't give correct output. So when that happens, sometimes it's really devastating for if your machine is not outputting the correct data, then you're not basing your judgment, or AI cannot be used at all if the input is wrong, right? And the third case is really the most common is that even if your software pieces are 100% in sync, in harmony, talking with each other, communicating perfectly, and if the monitoring results are calibrated, nothing is wrong. The worst case is that people are not really taking advantage of the data. And a lot of times we hear stories that, yeah, we have the dashboard, but no one's looking at it, right? Because the data is not actionable, right? So by AI in these kind of scenarios is that I think like our previous panelists have already like touched base on this kind of topic already, but here's like a brief overview is that how can we use AI is that a lot of times we can base on our performance on our past data and see like, okay, like if you're standing at like now and judging by our past data, up, right? But just like stock market, two things can happen. One is that your future will keep going up. The other is that your future has some kind of bottleneck that happens that prevents your productivity from increasing, and it actually plummets. So what AI is powerful of doing is that it can sort of like predict the possibility of that downfall and sort of like alert associated personnel of such delay reasons, and when do you expect that to happen, and how do you address that before it happens. So we have the example from the previous talk about how to prevent future maintenance needs, sort of like predict future maintenance needs, and sort of address that before it happens. And the other areas we can do that apply the same logic as well is that will we see any bottlenecks from a specific operator, or do we see bottleneck from a specific part number or specific client? And whenever that happens, we need to address that issue and feed it back to what you're currently doing right now and sort of fix it before the problem actually happens. So that's the power of AI, is to say, like, live machine monitoring tells you what's currently going on as a snapshot as of right now. And what combining AI with live machine monitoring is to take advantage of this kind of a monitoring concept and sort of like look into the future to see what's the current snapshot is going to look like 30 days down the road, 60 days down the road. So we achieved this by first by installing a machine monitoring system, and we need to make sure that it's compatible with all of your machines, that no one gets left out. And we make sure that it's in sync and is put to get together in the same place with your quoting software, ERP, MES, to be able to sync all the data side by side. So compare 4 most important matrices that we found so far. One is the how do you code it, and how do you schedule it, and how is it reported, and how is it measured. Because quoted is that you tell your client that like this is how much time it's going to take for the machines for us to finish the job, and schedule is that how when you put in your schedule, does it really make sense, and should it be should you leave this facility by what date and what time? And reported is that from your MES system, we see how it's being executed on the shop floor, and measured is from the monitoring system what's actually been going on, right? So our AI is able to put all four of them together in one place to display as a dashboard and also analyze in a cloud as an AI prediction to find any discrepancies between those four. And that's what AI Engine does. And only by doing that we can have full transparency on the shop floor. If we leave any one of those pieces out, then it's like we said before, it opens it in anyways, then you're like, it's kind of like the quote I always like to use is that half measure is worse than no measure, actually, in a lot of cases. So here I want to use an example of our partner, True Precision Machining. They represent a good example of using cutting edge technologies and also facing a very typical challenge that shop floors have, which is the high mix low volume or high mix high volume challenges. And here's their contact information if you ever need it. And here's an example of how we go about this journey is that, first of all, we make sure that the life status is reported on every single machine. First, how long the machine has been idled, and which job is machine is running, and also if there is any maintenance need, right? And when we do the part counts, how many parts has this machine be producing today? And the second step is that once we've made sure of that, is that we combine that with the ERP data to see what jobs are being scheduled right now and how it's being reported, and how's the actual operation reported from the machine, and comparing all those three, then we're able to really shrink the differences of all three. And the last step is that once we have all that, we'll be able to feed that information to AI and to identify really, like you can see the indicator of AI prediction. You can see what's actually going to be stay on schedule and what's actually at risk, right? Like in this case, for example, we know that we're seeing good results come for the included jobs, but then there might be some risk coming from this machine, for example. And the next step is that once we know how the machine was running, each machine per day, how it's running, we zoom out and see how it does per week, right? So we can look at the schedule, look into your future production schedule, and identify which jobs are supposed to have some delivery risk, and you can address those problems before they happen. And then the next step is that once you know there's a delay risk, then how do you address them? Where do they come from, right? We say that you can solve it before it happens, then where do you look at? And that's where the AI breaks down the possible reasons of delay. And in this case, for example, we see everything looks kind of good, and there's some spikes of risk coming from the client panel. In this case, we break it down to see which client is having the most highest possibility of delay. And then we break it down to see what are the possible affected job numbers, what are the affected work centers, and what are the associated technicians that can contribute to this delay. And this is the real life example of to verify the results of that, because a common thing to be aware of for AI is that everyone's AI, right? But really the truth is how accurate it is, right? So in this case, that about a month ago, we found some large alarming signal coming from the QA/QC department. As you can see here, 38% of the delay can come from the QC department. And as we can see that there at the time that is planned, we don't see any potential risk of delay. But what would actually verify 30 days later is that the QA actually took twice as long to run. And imagine how much power you can have, how empowered you are knowing that 30 days later, you can see what's going on 30 days later, and even before it happens, and how do you address that, right? So here's a little breakdown of what we do. Right now we're about 85% accurate in terms of identifying potential bottlenecks. And overall, that summarizes into $1 million of increased revenue in 1 year period. And some takeaway notes is that there's some existing challenges, and artificial intelligence can help with those challenges. And those that we mentioned are just for examples, and there are definitely other areas that AI can be applied. And really, there's no difference in like whether there's like a size of facility that doesn't fit or does fit for the use of artificial intelligence. And always a good approach is to start small and laser focus on something that really needs to be addressed first. And finally, that right now we're offering some. I think it's good to that we can test the AI. So feel free to, if you're interested in learning whether your facility can benefit from AI. Right now, we found it pretty useful to just send us some of the data you want to analyze. Then we can send you back the AI results and see whether it's a good fit or not. And these slides are downloadable from the handout section. So feel free to contact us if you're interested. And that's it.
Thank you, Ian. Thank you for the lovely presentation and giving a great insight. And in the second last slide, you summed up all the things which you wanted to say about what is going on in the manufacturing sector. Thank you, letting people know about Marta Inventive as well. So if anybody wants to connect with Dr. Ian, they can obviously connect him in the social media. LinkedIn is there, his company is there. You can obviously go to the website and get connected to him. Any questions, guys? Anything any one of you have? This is the last talk for the day. I'll just take a pause of 10 seconds. If you don't have the question, I'll just wrap it up. Dr. Ian, you want to say any last words?
No, just in general, appreciate opportunity, and overall, it's great to learn, the comrades that's just currently in this field, and definitely it's an upcoming field. There's finally gaining some. I think people used to not really believe in AI. People don't like to change until there's a crisis, which I think really COVID gives the opportunity, right? Because people were probably traditionally didn't want to adopt robotic arms on the shop floor, for example, right? But right now there's a labor shortage, then people are thinking about adopting it. So I think when there is a challenge, there's opportunity. Yeah.
You told one thing right. Unless people get an urge to change, they will not change. And
right.
and the COVID has given the thought process people how to adopt the digital technologies and all these. So AI, machine learning, deep learning, these are something which will be going on in the next few years as well.
Yeah. For sure.
Thank you. Thank you, Dr. Ian. See you, and we'll love to connect with you very soon.
Cool, for sure. Thank you.
Yeah, thank you. Thank you, guys. So just to wrap up, we would like to thank our technology partner, Digit7, and all our community partners who supported us, speakers, attendees, all our stakeholders who came together for enriching knowledge through this forum. Please log on to our website and like the social media channels, because we will be sharing lots of knowledge sharing topics, details, announcement of next events, and much more, which will help you register and attend the quality events with quality speakers. Just for your information, today's event was and is broadcasted live in the YouTube and Facebook channel of our company. So you all can go and see the recording anytime. Again, I'm reiterating, on September 28th, that is after 3 days, on Tuesday, next Tuesday, we are also coming up with a webinar with the theme, Learn How AI is Transforming Manufacturing Sector, and there are 4 quality speakers for that particular day as well. So the timing is 8:45 to 10:15 a.m. CT time. We'll send details to all of you so that you do not miss out on the same. There are lots more in store for subsequent months as well, with focus on cybersecurity, telecom, IoT, and blockchain. So these are 4 emerging topics for the next few months till December. So you just stay connected with us and enjoy the learning. Thank you all. Thank you all for the lovely day. Take care. Have a lovely weekend ahead. And I'd love to connect with you all in the near future as well. Thank you.
Okay.
Bye.